Hello guys, welcome back to my channel, Mason African Motives. Still working on O-level mathematics for Zimsec O-level. So we shall focus on this question paper which was written in November 2020, paper 2 paper, so that we just want to see how we are supposed to attempt these questions. So if you're new guys, you can consider being part of the family Mason African Motives by subscribing to the channel so that you won't miss any of the classes. And also for those with their question papers that they want us to focus on, as long as it's on Zimsec mathematics, then you can send the question paper so that we can focus on it. All right, so let us just quickly rush through the question. You are given on question 1a to evaluate 20 minus 20 divided by 5 times plus 3 times 2 or something like that, which is on 1a, and it has got 2 marks. So how do we actually attempt such type of a question? You are in paper 2 where you are given such type of a question. How are we going to attempt it? Seems like it's an easy question, but if you mistakenly attempt this question, then everything is gonna be wrong. So remember the concept of body mass. Body mass, guys, it still exists. All right, that is where everything started from. So we have to go back to where everything started from. Yes, you can use bomb dust, it's one and the same thing, but applying our body mass, we've got division and multiplication. So these two actually, they can go hand in hand. Remember, someone can use bomb dust, so which means these two, they go hand in hand. Division, multiplication. So we have got division here and we've got multiplication here. So these two, they go hand in hand. So we shall have 20, then we divide minus 20 divided by 5. You're simply dividing, guys, minus 20 over 5, which is actually minus 4. So this is minus 4 from these two. Okay, then you multiply these two, plus 3 times 2, which is going to give us plus 6. You are done. So you've applied division, multiplication at the same time. Then you are now at addition followed by subtraction. All right, so here you are going to properly add the two, 20 and 6, which is going to give us 26 minus 4, and at the end you obtain 24 from that. So that is actually what you are having in this case. So you have to be very, very careful how you attempt such typical questions, but that's what this is going to give us. What, 22, guys? Okay, not 24, but something like 22 there, because you're adding 22 plus 4, which is 26. I hope someone actually saw that. So I think these questions is just direct. Okay, on 1b, simplify, leaving your answer in set form. This is a square, so you have to square everything there. So you're given the square root of 10 minus the square root of 5, everything to the exponent of 2. So it simply means we have to raise this to the exponent of 2, that is multiply the bracket 2 times square root of 10 minus square root of 5 into square root of 10 minus square root of 5. That direct like that. Okay, so we know that we are going to multiply 10, square root of 10 and square root of 10. So simply applying your laws of sets, guys, we know that square root of a times square root of a, it actually gives us a if these two numbers are the same. So that is what you're having. So square root of 10 times square root of 10, that's a 10. Then we've got square root of 10 and square root of minus this 10, then it multiplies minus square root of 5. So this one, these two numbers, they are different. They are different. So you're going to apply this law when you are multiplying two numbers which are not the same, like this part, which are different. You just multiply them together under the square root, a times b. So in this case, you just multiply the numbers together, which is minus square root of 10 times 5, that's 50 there. All right, so let's just leave it for now. We shall simplify later on. We're done. We move on to this part here. We multiply. We are now with minus square root of 5 and square root of 10. So it's minus square root of 5 times 10, which is 50 there. All right, then we've got minus and minus, because you are now multiplying this bracket, this part to the other part here, which is negative and negative. that's a positive. Square root of 5 and square root of 5, we are back to that law that we used on square root of 10 and square root of 10, where we obtain 10. So which means 5 and 5, that's going to give us a 5 there. All right. Now from this part that we are having, we have managed to expand. So definitely what we have to do is to collect like terms, which are the numbers 10 and 5, which is going to give us 15. If you add, then here it's like you are adding. Take note, what you are simply having, this is simply the same as minus 1 square root of 50 minus 1 square root of 50. That is what it actually means. So it's minus 1 minus 1, which is minus 2 square root of 50, just like minus x, it's minus 2x, just like minus 1 minus 1x. So it's the same. This square root of 50, you treat it as x. Now you are having this answer here. Can you leave your answer like this? Definitely have to simplify, because we need square root of 50 in its simplest form. So we've got two options, either to give us the number that the two numbers which are going to give us 50, but one is a perfect square, which is 25 times 2, and we know that square root of 25 is 5 square root of 2. Or remember, I told you that way of expressing in as product of its prime factors, still you are going to obtain the same answer, which is 5 square root. So if you don't understand this, guys, make sure that you watch the videos on separate topics. Okay, just search your topic, then you type at Meson African motifs. Maybe you want to search surds, you just search surds at Meson African motifs. That topic you appear. All right, if there is no topic that we have not covered, then let me know so that I can work on it, because here we are just doing revisions, guys. Okay, we are not talking about a topic. All right, anyways, this is going to happen. You're going to multiply now square root of 50 with the answer that we obtained here, which is 5 square root of 50. So that will give us 15 minus 2 times 5, which is 10 square root of 2. So simply like that, you've got your answer. So like I was saying, guys, please make sure that you watch the videos on separate topics so that you'll be able to understand these question papers. All right. On 1C, we are given to find the LCM, which is the lowest common multiple of 15, 20, and 25. Remember what I told you guys, that you have to express these numbers as product of their prime factors. So you've got 15, 20, and 25. So you're going to express these numbers as product of their prime factors first. So the smallest number here, we've got 3. 15 divided by 3, which is 5. 5 and 5, which is 1. We move on to 20. The smallest number that we can use here is 2. 20 divided by 2, which is 10. We move on again to 10 divided by 2, which is 5. Then we can't use 2 this time, we have to use 5. So 5 divided by 5, which is 1. Then 25, the smallest number is 5. 25 divided by 5, which is 5. Then 5 divided by 5, which is 1. So which means 15 is the same as writing as 3 times 5. 20 is the same as writing as 2 times 2 times 5. Then 25 here is the same as 5 times 5. So that's what we have there. So therefore our LCM, which is the lowest common multiple, the one that I say that you take everything that is appearing, as long the term appears, you have to take that term. But when terms are maybe they're appearing, like what is 5 is doing, you take where you're having more values of that 5. All right, so let's start with 2. 2 is appearing. We are having 2 to appear, that is, it's there, it's present. Every number that is present, you have to take it. So 2, there are many here, so it's 2 times 2. Then 5, yes, we've got 5 here, we've got 5, but there are many here, so you take where there are many values. Okay, we left 3 here, we still have this 3, so we multiply by 3. So definitely we have to combine everything so that you can obtain the resultant, which is 2 times 5. If this is paper 2, so you can actually use your calculator, guys, and you're going to obtain 300 in this case. So that's your LCM. So let's just say the question wanted us to also find the HCF. Yes, it's not asked, but let's say they wanted you also to find the HCF. Remember, this one is a highest common factor, which is supposed to be common throughout. Remember what I told you guys, it is common throughout. So 2 is not common, we can't take it. 3 is not common, we move on to this 5, we've got 5, we've got 5, we've got 5. So 5 is common, so that's our highest common factor. Let's say they wanted you to find the highest common factor. It's a term or a number that is common throughout. All right. On D item 1, we're asked to express 252 as a product of its prime factors in index form. That is 2 marks. 252 as a product of its prime factors, but in index form. All right, so that's what we had on D item 1. So guys, how do you express a number as a product of its prime factors? You simply do what we did on those numbers when we were finding the HCF, the LCM, I mean. So it's just the same thing. So here the smallest number that we are going to use is 2. 252 divided by 2. This you are simply divided. This is paper 2. So we are going to obtain 126. Then divided by 2, 126 divided by 2, which is going to give you 63. Then we can't use 2, we have to try 3. 63 divided by 3, which is going to give us 21. Try 3 again, which is 7, 7, which is 1. So this is 252 as a product of its prime factors, which is 2 times 2 times 3 times 3 times 7. Then in index form, to the exponent of 2, because yes, 2 times 2, that's to the exponent of 2. 3 times 3, that's 3 to the exponent of 2. Then 7 is just 7 to the exponent of 1. There's no other 7, there is just 1. So that's 7 to the exponent of 1. So simply like that, that's what we needed. And then here we are asked to find now the smallest, take note, number by which 252 must be multiplied by to make the product a perfect square. So 252 is not a perfect square. If you find the square root of 252, that's not a perfect square, because it gives you a decimal. But a perfect square, that is actually a number just like a square root of 25, which is 5. So which means 25 is a perfect square. Okay, square root of 36, which is 6, which means 36 is a perfect square. So in order for you to have a perfect square, the numbers must be all in even exponents. These exponents that you are given here in index form, they must be all even exponent. That's a perfect square. What I'm trying to say is that if you are to find square root of 2 squared times 3 squared times 5 squared times 7 squared, even though I do not know the answer to this number here, the answer is going to give me a whole number. I want you to try to find the square root. You are going to obtain a whole number. That is to mean that this is a perfect square. So every perfect square is supposed to be having even exponent. 2 to the exponent of 4 times 3 to the exponent of 2 times 5 to the exponent of 4. This is a perfect square. Why? It is having even exponents. But now here we've got an even exponent, but this one is not an even exponent. That is 1. 1 is not an even number, it's an odd. So what are we going to do to make this number, because we want it to be an even number? So simply, as we can see, the smallest number that we can just make this to be a 2 is 1. If we add 1 here, because it's 7 to the exponent of 1 like this, if you add 1 like this, it is going to give you 7 to the exponent of 2, which now makes it a perfect square. So if you add 1 to the exponent of 1, therefore which number did you multiply with? Because these are exponents that you added. You are adding the index, the power. So if you are adding the power here, it means you were multiplying 7 to the exponent of 1 times 7 to the exponent of 1. That is what you were multiplying. So that means, because remember from your indices, when you are multiplying the bases which are the same, you add the exponents. That is what made you to add 1 plus 1. So the smallest number that you multiplied is this 7 to the exponent of 1, because you want the number that you multiplied. so that this can give you a 2. So you multiply it by 7 to the exponent of 1, which is just a 7. Take note, guys, if I was having 5 to the exponent of 3 like this, what I want is to make this in an even number, which means we're talking of 2, 4, 6, 8, and so these are even numbers. So definitely I'm going to add the smallest number, which is 1, to make this an even number, because 3 plus 1 gives me a 4, which is now an even number. But 5 to the exponent of 3 plus 1 means that you are multiplying 5 to the exponent of 3 times 5 to the exponent. This is what you are multiplying. So you are not focusing on the exponents you are multiplying, you are focusing on the number that you multiplied. We are talking of the smallest number that you multiplied, that must be multiplied to make a product. So that is why you see I ended up taking the number which is 7 to the exponent of 1, which is 7. So that's it. I don't know if you understand what I'm saying, but that's the concept there. So we shall move on to question number 2 and see what we are given and how are we supposed to attempt such type of a question. So you must be very careful with the information, how it is presented there. On 2a, we are given that the information, the following is an incomplete table of distances in kilometers between capital cities A, B, C, and D of 4 countries. Alright, so this is what you're given. Write down the distance from A to D, giving the answer in standard form. Take note, your answer must be in standard form. So this is what you're having. This simply means, guys, you must study this diagram. This table, what it simply means is that from this point A and B here, like this, A and B, this is the distance between A and B. All right, this is the distance between B, A, and what, and C. This is the distance between B and C. This is the distance between B and D. The distance between A and D. So you just combine like that, where they meet, that's your distance. So here we are given that the distance between A and D, which is A and D, where they meet at this point. So this is the distance here between A and D, which is 33,260. So this is 2A, item 1. So we've got 33,260 kilometers, but this must be in standard form. Okay, so remember, in standard form your number should be between 1 and 10. All right, so you're supposed to move comma so that this number is going to be between 1 and 10, which is 1, 2, 3, 4. So it's going to be 3, 3, 2, 6. This 0 is no longer important, times 10 to the exponent of the comma that we move 1, 2, 3, 4. So it's to the exponent of 4, which is a positive, because this number, it was a significant digit. So it's going to possess a positive what? A positive exponent, possess a significant digit. If it is 0, 3, whatever that you have, then the exponent is going to be a negative. The power here is going to be a negative, but this one is a positive. So that's it, guys. Then calculate the distance between C and what? C and D. So we want the distance between C and D. So if we are to cross check, yes, on the table there we are not given for C and D, that is where these two meet. So there is no way, guys. Just imagine, how can we calculate this distance? Okay, but there is something that we can actually consider, in fact. All right, I want you to understand this. This is the distance between B and C. All right, this is the distance between B and D. All right, there is something that is that I want you to relate there. Maybe it can make sense when I am writing this down. I want you to see something. We say the distance between B and D, that is from B to D, is 18,740. All right, kilometers. The distance between B and C, this one is 8,900. Between B and C is 8,970 kilometers. So it's like this. I want to want you to understand this. We want the distance from C to D. Okay, this is the distance that we want from C to D. Okay, I want you to take this in a normal consideration, because as you can see, there is a greater distance between B and D and lesser distance between B and C. So I want you to, okay, let's put this like this so that you can understand me. This is our B here, right? This is our C here, this is our D. So from B to D, this is your distance. From B to D, that's your distance of 18,740 kilometers. This is your B to D. From B to C, this is your distance here from B to C. From B to C. Now look where I'm indicating. This is B to C here, which is 8,970 kilometers. Now you want to calculate the distance from C to D. This distance in between here is the one that we want to calculate here. So how are we going to have that distance? So as you can see, it's simply this distance of BD minus BC. We are now having this piece, because if we add these two, they must give us the total distance of BD. So that's it, guys. So you must have that. This, you're not supposed even to do this in exam. This, you must have an imagination of this. You must have an imagination of this. But this diagram must be like your imagination. So I'm just presenting your imagination on a diagram like that. All right, so now we can have our CD. So our CD is equivalent to the difference, which is BD minus BC, or whatever that you are going to write, whether CB or BC, I don't know. So BD, which is 18,740, minus BC, which is 8,970. All right, so the difference between these two, which is going to give us 9,770 kilometers. So this will be our CD there. If you just finding the difference between what, the difference between the two, which is 9,770 in kilometers. All right, then let's try another question. This one, on question B, we are given that a 3-digit number is in base n. Okay, is given as, so this is a 3-digit number in base n. Write down the least possible value of n. Okay, so this n is a base, so the least possible value of n is going to be taken from this concept to say that, remember that when you are writing a base here, the base is supposed to be greater than the value that you are given. It's supposed to be greater than all these values that you're given. Like, let's take for example, I am in base 2. If I'm writing a number in base 2, definitely the numbers that I can only have in base 2, it's 0 and 1. If I am in base 3, this if I am in base 4, let's take note, in base 4, the highest number that we can have in base 4 is going to be 3. So which means that the least possible value is going to be a number that is greater than the highest number that we have here, which is the highest number is 7. So we shall have 147 in base 8 like this, which is going to be the least. Technically, just referring to the least number. So if this one can be in base 9, can be in base 10, but the least of these bases, the possible answers, but the possible answer was going to be 8, 9, or 10. But which one is the least? So the least is 8. So therefore, our n is 8, which is the least possible value according to this part. All right. Then we are now given that if 147 base n is equal to 3246 base 3224 base 6, find the possible value of n, and this is actually 4 marks for that. All right, this is what we are having, guys. In this consideration, we are given that if there is a base, because we said we have got two answers that we are assuming to have as our n here, because we said the least possible value is 8, but it can be base 8, it can be base 9, or it can be base 10, but this is the least that we just assumed to be our answer. Now they are saying, what is the value of n if it is equal to this number? All right, so this I'm going to formulate an equation, 147 in base n, which is equal to 324 in base 6. All right, so these two numbers, they are in different bases, so definitely it's going to be difficult for me to not to say these two are equal. If it was like these numbers are the same, then I was just going to take the base, but it's not going to be like that. So the only thing that we can have is to express these numbers in the same base, and there is only one base that they can be written in the same base, which is in base 10, because we can convert number from any base to base 10. So these two numbers can be converted back to base 10. They can be converted, all of these, to base 10, which is a normal base to simplify. All right, so now in base 10, remember, we're going to just raise in terms of the exponents. Here we've got n to the exponent of 0, n to the exponent of 1, n to the exponent of 2, so it's 1 times n to the exponent of 2 plus this is 4 times n to the exponent of 1 plus 7 times n to the exponent of 0, like that. All right, which is equal to, do the same here, so this is 6 to the exponent of 0 to the exponent of 1 to the exponent of 2, so it's 3 times 6 to the exponent of 2 plus 2 times 6 to the exponent of 1 plus here it's 4 times this, 4 times 6 to the exponent of 0, like that. All right, so you just have to combine the values here, n to the exponent of 2 times 1, which is n squared, plus n to the exponent of 1 is just n, so 4 times n is 4n. Any number to the exponent of 0 is a 1, so 1 times 7, which is 7. So this is equal to, you simplify this part, guys, this is going to give you 36 times this 3, but from your calculator, guys, you can just simplify this. All right, so you're going to obtain 108 plus 12 here, plus this is 4. All right, then just combine everything for n plus 7, which is equivalent to, so this is 124. All right, so transpose or collecting like terms this to the other side is going to be n squared plus 4n, that will be 7 minus 124, so 7 minus 124, which is going to give us actually minus 117, which is equal to 0 there. All right, so in order for us to solve for n there, as we can see, it's a quadratic equation that we have formulated. So for you to solve for n, you're going to have a lot of things. Either you're going to work with a quadratic formula, apply factorization. I don't know what you're going to do, but you have to find the value of n. So applying our factorization, in this case, since here the coefficient of n squared, it's a 1, what you simply need is to have two brackets. Remember, guys, what I told you, insert n and n here, then you focus with minus 17. What are the factors of minus 117 that you're going to add to obtain 4? All right, so these are the factors here. We've got 13 and 9. So, but in order for us to get minus, it's going to be minus 9. So that's 13 and minus 9. 13 times minus 9 is minus 117. 13 plus minus 9 is 13 minus 9, which is going to give us a 4. So you've got plus 13 here and minus 9 on the other bracket. So simply, either one of these brackets is equal to 0, and then n plus 13 is equal to 0, n minus 9 is equal to 0. So n will be equal to minus 13, or n is equal to 9. But this n is a base, so a base cannot be a negative, so definitely n is not equal to 13, so you have to cancel this one, but n is equal to 9. All right, so n is not equal to minus 13, that one you have to cancel it, because you can't say n is equal to, no, because we need the value of n which is find the possible. The possible is that one is a positive, not a negative. Okay. Then on 3a, they were given write down the number of degrees in 4 complete revolutions. So these are degrees in 4 complete revolutions. So we know that in a revolution, actually, we have got 360 degrees. Just a revolution. And here we've got 4 complete. So you just have to multiply by 4. So that's 360 times 4, which is going to give us if you multiply, that's 0 there. So let's just use our calculator, guys, which is 1440 degrees. Okay, that's it. Just multiply. Find the number of sides of a polygon whose interior angle add up to those 4 complete revolutions. So they are just saying the interior angle adds up to 4 complete revolutions. So the interior angle, remember how you find the interior angle. Just to find the interior angle, it's n minus 2 times 180. This is the sum of interior angles. And they are saying those interior angles, they add up to 4 complete revolutions. 4 complete revolutions. And we said 4 complete revolutions in degrees gave us 1440 here. So simply we are going to equate these to 1440. So we have formulated an equation: n minus 2 times 180 is equal to 1440. So for n, okay, you can expand by 180 or you can divide by 180. It's one and the same thing. So n minus 2 is going to be equal to this, and this will give us 8. So transpose minus 2 to this side is going to be plus 2. So n will be equal to 10. That's like that. Okay, so that's how you have it. Then on B, 2 similar containers of capacities. So whenever you are given capacity, that is volume, so you are given volumes there. All right. Then if the area, the surface area of the bigger container is 153 square centimeters, find the surface area of the smaller container. Find the surface area of the smaller container. All right. So this is it, guys. This is what is going to happen. Because here you've got volumes, remember. So this is what you are going to do. Remember from similarity, because this is similarity. This is a question on similarity, that one. We know that if you are given a volume, you're going to use what is referred to as the volume factor. So volume factor is the ratio of volumes, which is 1,728 as to the other volume, which is 5,832. That is your volume factor, a ratio of volumes. So definitely, in order for you to simplify a ratio of volumes, you have to divide, guys. You simply have to divide this value divide by this value here. So now what you're going to do, so that it was, remember, ratio, maybe you want to try to make it 1s to a certain number. So you're just going, ratio simply means to divide. So I'm going to divide by 1,28 by 1,728 here. So this is going to give me 1s2. So if I divide these two numbers from my calculator, you're going to obtain 27/8. So what does this mean to say 1s to 27/8? It means 1 divided by 27/8, which simply means 1 times 8/27. Remember, we have to invert the second fraction, which is 8/27. So this ratio of 1s2, which is 1 divided by, it is giving us 8/27. And 8/27 like this simply means 8s to what? 8s to 27. It's just one and the same thing. So this is the ratio of volumes, which is volume factor. But here you are given area, not volume. This is not volume, this is area. So in order for you to calculate the area that is going to correspond to the smaller container, you are going to find the ratio of areas first. So how do you find the ratio of areas? From the volume factors, which is the ratio of volumes. You have to first find the scale factor, which is when you are talking of size, that is the ratio of size. So the scale factor, you simply introduce the cube root here, which is when you are having a fraction like 8/27 as your volume factor. The scale factor is the cube root of this. So it's the cube root of 8, which is 2, over the cube root of 27, which is 3. So scale factor, that's 2:3. This is the ratio of just length of the containers. So if this is scale factor, but you are given area, which means you have to find area factor now from this scale factor. We have to find area factor. So our scale factor is 2:3. Therefore, what is the area factor? So area factor, it's a ratio of areas. This is ratio of what? Of areas. That is the ratio that you're going to use to calculate areas. That is area factor. So to find area factor, you simply square the scale factor. So area factor is equivalent to scale factor squared. That's it. So you just square the scale factor, so which means our area factor is going to be equal to scale factor, which is 2/3 squared, which is going to give us 4/9. 2 squared 4, 3 squared, which is 9. So that's your area factor, which is 4/9, or 4:9. That's our area factor now. So according to this ratio, this 4 definitely is representing the smaller container, and this 9 the larger container. So now they are saying the bigger container or the larger container has got an area of 153 square centimeters. So this 153 is for the bigger container. So it is the one that corresponds with the larger container, which is the bigger number here, which is 9. So 9 corresponds with what? With this area of 153. So what about 4, which is the smaller one? What is it going to correspond to in terms of what? In terms of area, you do not know. So whether that is less or that is more, that one does not matter. Whatever that you want this ratio of 4 in terms of its actual area. So it's 4/9 times 153. So this is paper 2, guys. Just apply your calculator. We've got the area of the smaller container. So if we apply our calculators direct, this is going to give us 68. 68 square centimeters. Just use your calculator properly there. All right, so that's it, guys. Then we move on to question C now, where we are given that the triangle ABC has got sides 6,5 centimeters, 7,8 centimeters, 9,1 centimeters for AC, measured to the nearest millimeter. So they were measured to the nearest, which means to the nearest whole number. So to the nearest millimeter, which means to the nearest, like a decimal place, like 0,1. Let's just say 0,1. All right. So which means this millimeter that you're talking, we had maybe for many digits, maybe let's just take example of 6,5. It was like 6, maybe there was 4, 5, 7, whatever that you have. So if you round off to the nearest millimeter, that is to the nearest this number here, this 5 is going to change this 4 into 5 like this. So that is what happened. Millimeter, that is to 1 decimal place, simply to 1 decimal place. Okay, to the nearest centimeter, that is to the nearest whole number. All right, because these are centimeters. I actually thought these are millimeters, but these are centimeters. All right, now they are saying express the length of side AB as a range in form of, so the range, guys, of AB is simply minimum to the maximum. So the minimum value here that you can have from 6,5 is going to be 6, just a digit less than 5 here, which is 6,45, like what I was saying here. But We just need 2 digits there, not because the other ones we do not know about them, because we are just talking about the least possible value. All right, so I want us to focus on this AB. If we are to write this AB as 6,5, that is the actual value which was given, the one that it was actually rounded off and it changed to 6,5. So now we have to ask ourselves to say which are the possible values that we can round off to one decimal place. Then we are going to actually have the 6,5. So definitely the first digit is supposed to be 1 less than this digit, which is 6,45, because if you round off, that 5 is the smallest number that can change this 4 into 5. All right, 2, this is going to be 6,5 is going to maintain as it is because it's now at its maximum. But which is the least possible value that is going to change? 5 again is going to change, but now we must be at what? At 4. So if we are starting from 6,45 up to 6,54, this is our actual range of values. But now I want you to see how the inequality is actually given here. It's given as AB. The way that we are given AB is greater than or equal to less than. So it is going to be greater than or equal, which means this answer is included. It's part of our answer. 6,45 is part of our answer. But 6,54 is not going to be, because they are saying the value is supposed to be less than. So if we say it's less than this, which means this answer is now excluded out of our answers, is not involved. So what can we do so that this answer is going to be involved? We are going to add 1 digit here, which is going to be 6,55. So we are saying AB is less than 6,55, which means we are now 6,54 is now included, but 6,55 is not included. When you say less than 6,55, 6,55 is not part of your answer, which means you're talking of any value that is less than 6,55, which means the first one is 6,54 up to 6,45. So that is what you're going to write in terms of what? In terms of the inequality that was given. All right, anyways, let us quickly rush to item 2 as to calculate now the least possible perimeter. All right, this is now the perimeter of the given shape, but we are working with the least possible perimeter for this triangle. All right, so that is what you're going to have, guys. So perimeter, remember you have to add the size. You have to add the size of everything. So that is your perimeter. So you are going to have least possible, which means you are going to work with the least values. All right. So here we are going to work with the least value. We say the least value here is 6,45. All right, plus we move on to another side, which is BC. So BC is 7,8, which means we are going to subtract 1 here, which is going to be 7,75. That is the least possible value that we can have. The maximum is supposed to be 7,84, but because we want to work with the least, we are going to take this one, which is 7,75, plus we move on to this one. It's 9,1, which means we subtract 1 here. It's going to be 9,05 up to 9,14. So as we are focusing with the least possible value, which is 9,05. So this is what you're going to do. So that is it, guys. So add everything properly. You're going to obtain 23. This is paper 2. Just use your calculator, guys. Okay, 23,25 centimeters. This is perimeter. So that is how it is going to look like. You are taking least values to calculate your perimeter. All right, so depending on the type of equation that you're given. Okay, now moving to number 4, we are given a matrix, a matrix A, matrix B, and you're asked to simplify in terms of x, a squared. All right, so a squared simply means a to the exponent of what? A to the exponent of 2. That is a times a. So A squared, this is your matrix A. You're going to square this matrix. 2, 4, x 3. You square this, which means you are multiplying these 2 times, which is 2, 4, x 3, just like that. All right, so applying our concept, guys, as we know, row by column, so that is it. So we're going to have this row versus this column. So it's 2 times 2, which is going to give us 4, plus x times 4, which is going to give us 4x. As you can see, this we can't combine these two, so we just leave it like that as 4 plus 4x. All right, we move on to this row, but to this column now. So it's 2 and x, which is 2x. Okay, then we've got x and 3, which is going to give us 3x. We are multiplying 2 times x, 2x. Okay, this row in this column, 4 row by column, guys, 4 by 2, which is 8, plus 3 by 4, which is 12. You are done. Then you move on to the last column, which is 4 and x, that is 4x, plus 3 times 3, which is going to give us 9 in this case. All right, so this is our matrix that you're going to have. So at least you can just try and simplify. Here there's nothing that we can do, just leave it like that. Okay, here you can add 2 plus 3, these are like terms, so you're going to obtain 5x. 8 plus 12, these are like terms, which is going to give us 20 here. And these we've got unlike terms, so there's nothing that we can do, just leave it like that. So that is what you're going to have as your a squared in terms of what? In terms of x. All right, so that's how they ask some of these questions. You just need to be very, very careful. All right, then AB again in terms of x, which is matrix A times matrix B. All right, so we simply substitute what we are given in this case. That's AB, which is matrix A times matrix B as it is. So it's 2x 4 3. This is your matrix A times, which means you are going to multiply your matrix B, which is 5 minus 1. All right, so that's it, guys. You apply your row by column, but your answer is supposed to be in terms of x. So as we know, guys, row by column, this is our row, and we just have a single column here. So it's 2 and 5, which is going to give us 10, plus x times minus 1, which is minus x. Take note, we've got a single column, so these two are adding. You're not separating 10 then minus x like that. No, these two, they are adding. We are still in the same row and the same column. That is why we have to add. Then we move on to this row and this column. You write it down now. So it's 4 times 5, which is 20, plus 3 times minus 1, which is minus 3. So which means we are going to have a 2 by 1 matrix there. So 10 plus minus, plus and minus gives us a minus. So it's going to be 10 minus x. Then you have got 20 plus minus 3, plus and minus, that's a minus. So it's 20 minus 3, which is going to give us 17. So that is going to be our AB. So as you can see, on this consideration, we are just combining terms which can be combined, but for unlike terms, don't simplify, just leave it like that. All right, then let's see what we are given on the other part. They are now telling us to say if matrix A is singular, then find the value of x. If A is singular, this matrix A. Okay, what do we know about a singular matrix? We know that for a singular matrix, this is a matrix which has no inverse, so which means its determinant is equal to what? Its determinant is equal to 0. So you're going to simply find determinant and equate to what? To 0, where you know that determinant is the product of the major diagonal minus the product of the minor diagonal. So you're going to multiply 2 and 3. So that is what you're going to have. So determinant of A in this case is equal to 0. That is determinant of A like this is equal to 0 for a singular matrix. So 2 times 3, you are now calculating the determinant in terms of x. Remember, determinant, we said product of this major diagonal minus the product of the minor diagonal, which is x and what? 4. So it's going to be minus 4 x, 4 times x, which is 4x. We must obtain the determinant of what? Of 0 there. So we are now back to a normal equation. 6 minus 4x is equal to 0. 6 transpose minus 4x so that it can be a positive. So you want to find the value of x, so you can divide by 4 both sides, so which means our x is going to be reduce both sides by 2. That will give us 3/2. So this is the value of x, which is same as 1.5. You want to write as a mixed fraction, but your x there is 3/2 according to the information that you're given. All right, so that is the condition that is going to make A to be a singular matrix. All right, then on number C, which is actually a question which is under sets, there we are given the information of learners who attended a trip, in this case from a primary school. They had to choose where they are supposed to go, either Peshnav Bridge, Great Zimbabwe monuments, or Matopo monuments. So they had to choose between these Peshnav Bridge, Great Zimbabwe, Matopo, and so forth. So the following statistics were gathered, which means that is the information which was taken into consideration. The number of those who wanted to visit Great Zimbabwe, Peshnav Bridge, Matopo. Then we have got 10 who wanted to visit all the 3 places. So take note about this part, who are visiting all the 3 places, and 6 were not taken to visit any one of them. And this part, we are not part of our information that we have. The 19 visited both. Okay, these ones I'll talk about them. So from this information, there is a part that was actually constructed or given, and not like everything, but just some of the information we are given. Said those who represent Great Zimbabwe, B, Peshnav Bridge, and M, Matopo. All right, then here is what we are given, some of the information that we had. Then we are supposed to complete this, because that is what we have, guys, in this case. Okay, so let's see the information that we are given and the one that we are supposed to fill in. All right, it's best to fill in from these two that I was talking about here, because here we are given that 10 wanted to visit all 3 places. Because here, if you are given that 39 visited Great Zimbabwe, this is the whole of this set here that we are talking about. The same with Peshnav Bridge, the same with Matopo. We are talking of the whole set that you'll be talking about. So it is going to be difficult for us to find this part or to find the remaining, because you are supposed to take, okay, let me write it so that we can understand me. This is Great Zimbabwe, guys, which is 39. Great Zimbabwe here. So let's just write 39, which means the whole of this set has got 39 elements. All right. Then Peshnav Bridge, which is 31. So this one has got 31 elements, the whole of this set. All right. Then Matopo, it got 30. Here we have got 30. All of these who are in this set is 30. So which means if you add this part and this part and this part and this part, they must give you 31. So it's going to be difficult for you, because you are not given this part. So you have to fill in the information that is exact. That is why I said we must focus with this part, which we are given that 10 wanted to visit all 3 places. So which means we're talking of the intersection of all the 3, which is 10 here on the intersection of the 3 sets. All right, then also this one is clear, because you are given that 6 were not named to visit any of the 3 places. This is nin, guys, which means they did not want any of these places. So we're talking about people who are not part of these sets, 6 outside of the set, like that. So we've got 6 who are there. All right, then what else do we have? Then we've got these ones who are given both 19. They visit both Great Zimbabwe and Peshnav, which means we are talking of Z and what, and B. 19, they are in both, to say in between this. So like if you cross check, 9 plus 10 gives us 19. This is to correspond, say this is true, because we're talking of in between these two. We've got 19 elements here. All right, the same between Great Zimbabwe and Matopo, we've got 15. This is our Great Zimbabwe and Matopo here. In between here, we've got 15 people who are inside. Remember, this is your Great Zimbabwe and Matopo here. That is where we've got 15 people. But now we have got these 10, so which means we are going to remain with what? with 5. Also, we could have obtained this 5 in another way. We could have obtained this 5 because we know that in Great Zimbabwe here there are 39 who are there. So we are going to subtract 39 minus 15 plus 10 plus 9 plus 10. You add these two, you subtract them from 39 like this. We could have obtained this value by subtracting 15 plus 9 plus 10. This is what you subtract: 15, 9 and 10, this, because you want to calculate this value. So we could have calculated this value by subtracting these values from what? From 39. So we are going to subtract the total of this from 39. So you are going to obtain the same value of 5. All right, so let's see how we can fill in. We are left with this part. I think, yeah, that's the only part that we are left with. How can we fill in this part, guys? All right, if you are to see here, we are given that these are 17 is fine, but we can add everything here, which means if we add everything including this part, we must obtain 31, because in this set B there are 31 elements. All right, so we are going to subtract this from 31 just like what we did for this one. So we are going to subtract from 31 this time. So it's 31 minus, which are the elements that we have in B? We have got 9, 10 and 7. So we've got 9, 10 and 7. We subtract this from 31 and that is going to give you 5. Okay, so this one is going to give us 5. So make sure that you subtract properly, guys. Open your bracket. This is calculator that you're using. Paper 2, use your calculator like that. All right, so we have completed this information, this Venn diagram. Then the question on item 2 is to write down the total number of grade 3 learners. Therefore, what is the total? So the total, you are going to add everything that we have here. We have got 6 outside here, so this is item 2. So our total, we are going to have 6 outside. We have got this 8. In fact, we add everything: 8, 5, 10 and 7. So you're going to add these. Okay, 8, 5, 10 and 7. Okay, we move on. We have added, we are left with 5, 9 and 15. So you add everything: 5, 9 and 15. That's what you're going to do. So you have to add all the terms that you're given, and this is going to give you 65 if I'm not mistaken there. So you just cross check, guys, if we are obtaining the same answer or the same values there. But that is the consideration that you were given and what you're supposed to do from this part here. All right, so guys, as we can see, let's see another question, which is the B part. On number 5B there, we are now given a question which is under construction. All right, where we are asked to construct a triangle. So as you can see from this triangle here, guys, we've got triangle PRQ such that QR 7.5 centimeters, PQR 90 degrees, and these. Okay, so you just try to make a sketch, but make sure that on your sketch these angles, they are on the what? They are on the base of what? They are on the base of the triangle. All right, so this is what you're going to have. We can just choose to say because this is actually a right angle triangle, because as you can see there's an angle of 90 degrees. So your sketch must also be meaningful, guys. Okay, you must just have a sketch which is also meaningful. Okay, so this is my sketch here. So this is 90 degrees here, which means this is my point Q. Q is the angle here, so that's our Q. Then we have got an angle of 30 degrees. Make sure it's on the base, which is 30 degrees. I'm going to put it here on the base, and this angle of 30 degrees is at point what? At point R. All right, then we are left with what? With P, like that. So this can be our sketch. Then we are given QR is 7.5. From Q to R we have got 7.5 centimeters. Therefore we must construct this. Okay, so what we are going to do actually is to make sure everything is in contact, guys, whenever you are working with such typical questions. All right, so I'm going to have my line in this case where I'm going to construct this. All right, so I'm going to use just a normal line, guys. All right, just a normal line. Remember, everything has to start from a line, so that's what you're going to have. So you just draw a line, in this case like the one that I'm having. Maybe you don't measure the exact distance that you're given. No, that one you're going to do it when now you are constructing. All right, so let me show you guys what you're going to have in this case. I think it's going to be easier. And the other thing, also make sure that this is supposed to happen here. This is supposed to be within the range, like whatever that you're going to have is supposed to be like this. Like these two should be close to each other. All right, like they must have actually same length, but you make sure that your pencil or the pen that you're given is just a little bit bigger than what than the needle that you're having in terms of length there. I don't know if what I'm saying is clear. All right, so this is it here, guys. Let us construct our 7,5. So we shall measure 7,5 per first, or we can just mark our point. Okay, let's just mark our point first. It's because of this thing now, there's too much right here. Okay, so I'm going to mark it here. All right, so this is my first point that I am going to refer as what? As Q. So this is going to be my point Q. Then from Q to R, I'm having 7,5 centimeters. So now I can measure my 7,5, which means it's in between here. All right, 7. All right, so make sure that you are at 0 here at the starting point. Okay, up to 7,5. So as you can see, guys, 7,5 is somewhere in between here. All right, that's my 7,5 there. All right, so you just make sure that you measure a little bit properly, guys, so that you don't have any challenge. Now is because I want you to see, and I'm also explaining this, but as you can see, this is how it's supposed to be like. Okay, and I think, guys, this part we are now used to it, but I just want to make all of us understand what is happening here. So pardon me, guys, for this question, because I want us all to understand what's happening here. All right, so this is going to be our point R. Remember, these are the ones which we say they're in the same line. So this is going to be our point R, this one. So we are now having our point R there. All right, so what else do we have? We've got these angles, 90 degrees at Q, 30 degrees at what? At R. So we just need to construct our 90 degrees, guys, as we know. 90 degrees from Q. How do you construct 90 degrees? Remember, I told you guys that you have to mark 2 points from what? From that point where you want to construct 90 degrees. Sorry for that. It's because this thing that I'm using is actually big. I want something that is clear, so I'm not having a smaller thing here. That's why it's affecting like this, but I hope you see the idea there, because you are supposed to use a smaller than your canvas there. Okay, so now let us construct our 90. So what you're going to do is to just open more than half of what? Of the distance that you have from these 2 points. You just more than Q, that is more than half. All right, then you construct an arc on top. You also construct another one down, but because already there's a point here, there's no need for you to construct this one. Yes, you can construct if you want, but there's no need, because you know that it is going to join back to what? To Q here. So let's do another one here. All right, so just like that, guys, you join your point. So like I was saying, that we could have done or drawn another on down here, but there's no need, guys, because already we are having a point of reference, which is Q. So this line, try to draw try to make it bigger. Okay, so this is your 90 degrees here that you're going to have inside. But when you are constructing, you cannot even write this because already it's there. Okay, they are going to measure these things or these values. Okay, but your QR here is 7,5 centimeters. Also, they will measure this. All right, Then we move on. We need 30 degrees. Remember, at R here we need 30 degrees and 30. We have to construct it from 60 degrees. Remember, guys, you have to bisect 60 degrees. So we're going to construct 60, and it's supposed to be inside our shape. So you construct it this side because it's supposed to be inside of your shape. So you construct to the left side, all right, because it's supposed to be in the shape that you're working with. So remember how you construct 60. If you don't know how to construct these angles, guys, from basics, make sure that you watch the videos on construction on the basics. Okay, and we move on like this. So this is our 60 degrees. I'm just going to put it in with a broken line. So there are so many ways that you can actually avoid to do this part of bisecting, drawing 60 then bisecting, where you can do it direct, but let's just use the one that we are used to. All right, so now let us bisect this angle. Remember to bisect, these are the 2 points which are making the angle 60 degrees. So these are the 2 points that you're going to use. Mark an arc inside. Okay, then you mark also from this point inside. So these, they are going to actually intersect at a certain point. Where they do intersect, that is where you are going to join, going inside like this. So that is how it is going to look like. All right, so let's just hope everything is perfect there. So that is how it is going to look like. So now we have bisected this angle of 60 degrees, meaning to say this is going to be 30 degrees here, because the whole of this angle was 60, but it's now 30. But you write this one, this is the one that you need, which is inside the shape, this one. So that's your 30 degrees. And also definitely where these 2 points are going to meet, because we know that our triangle is PQR, and P we did not know its actual position, but we know when these 2 lines meet, that is where our P is going to be. So these 2 lines, as you can see, they are meeting at this point. So which means at the point where these 2 meet, that is your P. So this is going to be our P, just like that. So also to measure your angles in exam is very, very important, just to cross check if your angles are in line with what you're given. Okay, this is 30 degrees, as you can see. This line passes through 30. This is 90 degrees also, as you can see, this line passes through 9. So it's very, very important that you just cross check your angles to see if they are the ones that you're actually given. All right, so that's what we had, guys. So this is actually part of our question 5 there. All right, so that is 5 marks for that. Then on item 2, to construct the locus of points equidistant from P and R. So this is equidistant from P and R. This is locus. So remember, locus, from 2 points you bisect the line. From, you are given 2 points, in between 2 points P and R, you bisect P and R here. These are the 2 points that you're given, so you bisect that line. And remember, to bisect a line, you have to open more than half of the line from the point R here. You're going to open more than half of the line. We just construct an arc from another end and another an arc on the other hand, without changing these dimensions that you have. Without changing these, you use as they are. Don't change the dimension that you have here. All right, so you're going to use this as they are, but now you are at point what? You are at point P. All right, this is our point P. So guys, also the way that I'm sitting and the way I am putting this set up, but I hope you see what I'm trying to represent there. So this is how you're going to do it. And we just combine or just join these 2 points where they meet. So make sure that, guys, you actually watch the videos on the introduction of this, because here's just an application. So we have managed to bisect the line PR, but it was given as a locus. As you can see, they didn't even tell us to bisect, but the way the question under locus, the meaning of the question under locus, coming back with it to construction, it means you have to bisect. So you have to know all the 4 concepts of loci that you're going to use to convert back to construction. All right, anyways, let us quickly rush through this one, which is to construct the locus of points 3 centimeters from Q. So remember we talked, this is a fixed point. So locus of points equidistant from a fixed point, that is what? A circle. So you're going to draw a circle which is 3 centimeters from Q. So definitely we have to measure 3 centimeters so that we can draw that circle. Okay, so 3 centimeters. This is where we are going to have our 3 centimeters here. I hope, yeah, somewhere there. So with these 3 centimeters, I'm not going to change it. I'm going to work with it. So we said we are going to construct 3 centimeters from Q, which is a circle from Q. All right, so this is our Q here. Point at Q direct. All right, we are at Q. Then you draw with that 3. This is 3 centimeters that you've measured. So definitely the moment you construct from Q, you are going to have a circle that is from Q. Q is a point. So that is what you're going to have, guys, in this case. So just like that. So what matters is this part. We are given a point. It's a point Q. But if it was 3 centimeters from, maybe they say 3 centimeters from QR, QR is now a line. So 3 centimeters from QR is the one that gives us what? A pair of parallel lines from that line that is 3 centimeters from a line. You produce a pair of what? Of parallel lines. But 3 centimeters from a point, it's a circle. This one, you draw a circle. This one, it's a line bisector. You bisect the line. All right. Mark and label D1 and D2 that are equidistant from points P and R and 3 centimeters from Q. Okay, which means we are simply combining these two loci. As we can see, the first locus and the second locus are the ones which are being described here. So where are we going to find these two loci intersecting? The first one, it was a line bisector, which is this one. The second one, it was a circle. Where are these two meet? Where do these two meet? They meet at this point here, where these two loci meet. Also, they meet at this point here. So these are the points that you have. All right, so let's see what we have here on the other part, which is actually section B, which is on number 6. As we can see, we are now having a condition where you're answering 4 questions on that section. So yeah, we are just going to work on everything, but as for you, you're supposed to choose any 4 from this section that you have. So we shall see the first question that we are given on question 6. We are given that Mrs. Chua, this one, invested a certain amount of money with a bank that offers 4.5% per annum simple interest. Okay, so this is a simple interest that you're working with. So you're given the percentage, that is the interest rate, okay, per annum, that is per year. After 8 months, a money amounted to, that is the amount that we have after 8 months before any bank charges were deducted. That is the total amount. Okay, then calculate the amount of money that Mrs. Chua had initially invested, which means we are referring to the principal in this case. Okay, so what you're going to do, you're working with simple interest. You're just going to list your information. What do we have? We've got the interest rate in this case. That is your the interest rate, which is 4.5%. All right, so what you can do, because you're going to work with this value as a decimal fraction from a percentage, you know that we divide by 100. So you're going to divide by 100, and that is going to give us 0.045. If we divide by 100, this is paper 2, guys, just use your calculator. Okay, you're going to obtain 0.045, and we are given that after 8 months, that is the time frame. Remember, our time is supposed to be in years. Okay, so okay, let me write the formula. Maybe it can help us, the one that I'm going to use, so that you understand how am I listing this information. We know that the amount is equivalent to P into 1 plus NT. That is if you are working with what? If you are working with NI in this case. Let's just NI, yeah, so that it cannot confuse us, guys. NI here, not NT, because this N is going to be the number of years, then this I be our interest. All right, so we've got 1 in this case. This is your principal, okay, that is the money invested. This is the total amounted, which amounted to, then this is the number of years, this is your interest, okay, which is your I in this case. So N, I'm going to put it as my number of years. All right, so in this case we have how many years, guys? We've got 8 months. So 8 months in years, that's 8 over 12. So this is 8 over 12 years. All right, it's now in years, because remember in a year we've got 12 months. So we are given that the amount amounted, which is, this is your A, the total amount, okay, that is your A, which is the total amount of $504.70. All right, so the question is asking us to calculate the amount that Mrs. Chua had initially invested, which means the principal amount is the one that we want to calculate. So what we can do is to play around our formula, substitute our values. Yeah, I think that can be possible for us to do that in an easier way. So the amount, substitute your amount here, that is the total amount that amounted, which is 504.7. so this 0 is just for amount. So when you are calculating, there's no need for you to put that 0, just leave it, okay. We want to calculate P, which is the principal, the amount that was initially invested, that is 1 plus N, which is the number of years. We said we've got 8 years, so 8 over 12, sorry, so it's 8 over 12 times the interest rate as a decimal. So you're going to write this as a decimal, which is 0.045 as a decimal, like that. All right, so that's it, guys. You can calculate our P here. That's 504.7 is equal to, so if you are to multiply these two, we are going to be left with 1 plus, if you multiply these two, you're going to obtain a decimal of 0.03. All right, so that's what you're going to have. So if we add this, it's going to be 504.7, which is equal to 1.03 P. Okay, so you add these two, then you multiply to P. So what can I do to calculate P? This is just a normal equation, guys. Divide by 1.03, both sides, 1.03, both sides. So as you know, if you have got the formula, it's going to be easier for us. All right, so this is the principal amount that we need, which is going to be in dollars. All right, so you're going to obtain 490. So just like what we saw, the money was given to 2 decimal places, so you just write 2 zeros or just 490 like that. It's fine, but 2 decimal places for money, just to indicate you are working with money, guys. Okay, but anyways, just like that, your answer is also fine. So that's what we had, and now they are telling us on item B, we are given that there is a Mrs. Bande who bought a set of sofas for $380 cash, including 15% VAT, which is the value added tax. So whenever you're given VAT, that is an added tax. Calculate the price of these sofas excluding VAT. Excluding, that is when you remove, okay, that is to exclude. So if we are excluding VAT, in this case, this is excluding VAT, which is the value added tax of how many percent? Of 15%. We are given a value added tax of 15%. So now they are saying exclude. From your English, guys, this is to remove the value added tax. Like when you buy your t-shirt or you buy your nice sneakers, they are going to have a value added tax. The sneaker itself, it will be costing you 1,100 rand in this case. Then due to the VAT, maybe they added a tax to this amount, you end up maybe seeing something now costing 1,500 rand, like that. So each and every item that you buy, it is having a tax that is on it. which is depending with where you are from, but as we can see, mostly 15%. In this case, we are given a 15%. So in this case, I'm just explaining about a text, but about this question, let us just quickly write through it because we just remove the 15%. Okay, so that means we have to calculate the 15% of the price, which is this amount, or we can use that concept. Remember guys, I told you to say anything that before anything was added, it is at 100%, and I think that thing is supposed to help us a lot to say that. Okay, let me do it this way. Remember guys, I told you about these percentages from a paper one, that whenever there is an increase, this is the easiest way. Whenever there is an increase like this one, it's a VAT, it's an added tax. This one added, which means it's an increase, which means originally before the sneaker that you wanted to buy was priced at 1,100 rand, then a tax was added. Before that tax was added, what does it mean to us? It means that price was at 100%. So you are the one that is selling a certain product. Okay, you think of a certain price to say, okay, I'm going to sell my items for this amount. Then there is a tax which is added. So you're saying your price is 100% price because you are the one who has initiated that price. So this is the price that we want to know, which is at 100%. But we are saying now, after we have added 15%, we are now having a certain price. So what is this 15%? We are going to add to 100. So when we added 15%, which means we are going to add, is going to be 115. That is when you add 15 to 100. So at 115%, the cost of the sofas now was at $368. So what was the price when it was originally at 100% before the tax was added? What was the price? So definitely it's going to be a lesser price that we are going to have. So it's going to be 100 over 115 times $368. So our answer is going to be in dollars, which is going to give us $320. So just imagine guys, if there is no tax, then this lady was going to buy these sofas at $320, but because the government need the tax, it's now at $368. So that's the case that you can simply do in this case. Okay, then we are given that on item 2 that Mrs. Ndlovu, guys, these some of these names, okay, decided to buy a similar set of sofas on lay-by. So a lay-by term is whereby you deposit a certain amount, then you keep on paying monthly installments in order to finish that product so that you'll be able to take those sofas. So this is what happened. On a lay-by, Mrs. Ndlovu had to deposit $150 plus 3 equal monthly installments of $87, including VAT. So which means all these payments were having VAT. Calculate the difference in the amounts of the money of the two customers. So we are going to calculate the difference when there is VAT, which means when Mrs. Bande bought the sofas at $368, including VAT, and when this Mr. Ndoro had to buy the same type of sofas but on a lay-by. Okay, so let's start by knowing what was the total amount on this lay-by. What was the total amount on lay-by? So on lay-by, we had a deposit, that is the money that is deposited, which means 150 was given, 150 that is deposited, plus that is you're going to add 3 equal monthly installments of $87. So we are saying each and every month he is paying a certain amount of $87 for how many months? For 3 months. So what was the total? We are just going to multiply. Instead of adding 87 plus 87 plus 87, you simply multiply 3 times 87. That is what it means. So definitely that is your total amount. So 3 times 87 from your calculator, guys, this is going to give us something like 261. Okay, so if we add these two, that is going to be 411. Okay, so this is for this guy, Misty Law. This is the one that had, was it supposed to be Lore or Love? So supposed to, I don't know, but this is Ara, guys. Just look proper. Okay, so this is the amount that he had, including the VAT, which is the value added tax. But here we are asked to calculate the difference in the amounts of the two customers. The first customer had to buy a 368, including the VAT. That is a 368. So what is the difference? We are going to subtract. So the difference in their amount is going to be this one, with a bigger amount of $411 minus the one who bought this on cash. So as you can see, guys, if you buy things on cash, you buy actually at a lesser price than the one who do lay-by. If you do a lay-by, it is going to cost you a certain amount on top, okay, just like a higher purchase. Okay, let's subtract the two. We are going to have $43 in this case. So that was a difference of $43. So you can even write as 43,00 because it's money, depending on how you want to express it. So that is what we obtained, guys. All right, let's see another question. Is this question? Okay, here on item C, we are given that the average expenditure E of a family over a certain period of time is partly constant and partly varies as the number n of people in the family. Okay, that is a partial variation, guys. As you can see, sum of two parts. So the first question is to find a relationship between E and N using constants H and K. So we're going to introduce constants H and K, but take note, the first part there that we have, guys, that we are given is that it is partly constant. So if you have been watching the videos on variation, guys, I hope you understand how you are going to write this. So this is going to be C item 1. So E, that is our expenditure, is equal to, you don't use variation sign when you are working with partial variation, okay, is equal to partly constant. That is a constant. So you're going to introduce the first constant. So I'm going to introduce H because it's partly constant. That is a constant without any letter there, okay. And that is, you're going to add partly varies as the number n of people. So it's now a constant and the number of people. So and we're going to add the constant times the number of people. That is our partial variation. So this is what you are being required to write on this first item, okay. Then now we are given that the expenditure of 5 people is $55 and for 3 people is $45. Find the value of H and the value of K. So when you are working with partial variation, remember, guys, how do you solve these constants? You have to substitute here n, which is 5 for the number of people, 55, which is the expenditure is $55, and the expenditure is represented by what? By E. So this is item 2. I'm going to start by substituting here. E, that is the first part, is $55 when our number of people is 5. Okay, so 55 is equal to H plus when number of people is 5. So it is going to be 5K. All right, we move on to another part. For 3 people, it is $45, which means our expenditure is $45 when we have got 3 people. So it's going to be 3K. We're talking of number of people, so it's going to be 3K. So you have formulated simultaneous equations which are going to enable you to find the value of H and the value of K. So you're now, this is no longer about variation, guys. This is no longer about, you are now back to your normal simultaneous equations. How do you solve simultaneous equations? Because this is no longer about variation. It's about your simultaneous equations now. Okay, so already the value of h here, the constant h is the same, so we can easily eliminate h by subtracting. So we can eliminate h because it is the same here. We just subtract 55 minus 45, which is going to give us 10. H minus h, that's s0, so which means we've eliminated h. So we're going to be left with 5k minus 3k. 5 minus 3, which is 2k. All right, so to find k, definitely I have to divide by 2 both sides, which is going to give us 5. So with this value of k, I'm going to use it now to find the value of h, choosing any one of these equations. So if you can see, if I can transpose this to this side, it means 55 minus 5k is equal to h, because I want to calculate h, so I can easily make h to be the subject or just substitute, is fine. So 55 minus 5 times k, our k is 5, is going to give us the value of h. So that's it, guys, from your calculator. 55 minus 25 is equal to h. So h is equal to 55 minus 25, which is 30. So that is what the question is asking you to do, just to calculate the value of k and the value of h, the value of h and the value of k, nothing from that. So you just, that is the question, you are done. Okay, so answer the question when you are in exam. Don't say it's variation, so I'm supposed to do this because I'm under the topic of variation. No, answer the question that you are being asked. Okay, on number 7a, we are given that there is a rectangle, okay, with a width and as a perimeter of, find an expression for the length. Okay, this is a rectangle that we are given, guys. Just a sketch. We know that if I am working with a rectangle, in this case it's definitely, I'm referring to the length and what, and the width. So in this case we are given the width of the rectangle, which is x plus 2, which is here. We've got x plus 2 here, we have got x plus 2 here. That's our width. And we are given the perimeter, that is, the perimeter is 8x plus 2. That is your expression for the perimeter, definitely in centimeters. Then you're asked to find an expression for the length of the rectangle, which is the length of the rectangle, this one, L. So we do not know this expression, but we want to find this in terms of what? In terms of x. So how are we going to find this expression for the length in terms of x? We are given perimeter, guys. So you just ask yourself, how did you manage to obtain this perimeter? That is the question. What was the formula for the perimeter? Okay, we know that this is a rectangle, so the perimeter is equivalent to, perimeter of a rectangle, remember, is 2 into length plus width. That is your perimeter. As in this case, we want to calculate this value of L, so we can actually play around this formula, that is perimeter is equivalent to 2 times L, which is 2L, 2 times the width, which is 2W in this case, which is our width. Let us make L to be the subject at once, then we'll be done. So we are going to make L to be the subject, transpose this to the left hand side, is going to be P minus 2W, which is our width, which is equivalent, you'll be left with 2L in this case. What do we want to find? We want to find the length, so divide by what? By 2, both sides. So the moment we divide by 2, we are obtaining an expression for the length in terms of perimeter and the width, which means our length is equivalent to the perimeter. I'm going to substitute now the perimeter. This is our perimeter. Okay, 8x plus 2, that is your perimeter, minus 2 times the width, which is 2 times the width. In this case, our width is x plus 2. So you put this in a bracket because you're subtracting. So this one you can put in a bracket, but it does not affect us. Okay, everything over 2. So this is your expression for the what? For the length. So you can simplify further, which is 8x plus 2 minus 2 times x, that's minus 2x, minus 2 times minus 2, which is minus 4 over 2. So collecting like terms, guys, as you can see, you've got 8x and 2x. So you have to subtract there, which is going to give us 8 minus 2, that's 6x. 2 minus 4, which is minus 2 over 2. So this you can easily divide, because just like, guys, if you're given a plus b over 2, it is the same as a over 2 plus b over 2. So you can separate this 6x over 2, which is going to give us 3x, minus 2 over 2, which is going to give us minus 1. So this will be your length in terms of x. Or you can simply do this, guys. Perimeter is equal to the length plus the width plus the width, like that. You substitute your values here, just like that. Perimeter, I have got my perimeter. Let me use this. 8x plus 2, that's my perimeter. 8x plus 2 is equal to length plus length, which is 2L, plus the width. Our width is x plus 2. So you've got x plus 2 plus x plus 2, just like that. I can still find the value of L in terms of x. So this is going to give us 8x plus 2, which is equivalent to 2L. Collect like terms, 2x and 2x. I mean x and x, that's 2x, 2 and 2, which is 4. So definitely I can transpose this to the other side of the equation, which is 8x minus 2x, that's 6x. 2 minus 4, which is minus 2, is equal to 2L, which is the length. Remember, what am I supposed to calculate? I'm supposed to calculate the length. So divide by 2, by 2, by 2 each and every term. So I'm going to cancel 2 into 6. That is 3x, 2 into minus 2, minus 1, which is equal to L. So as we can see, guys, we are still obtaining the same value or the same expression. As long as you understand the concept, this is a mathematics, guys. It's a matter of understanding the concept and how to apply the concept properly. That's the case. Okay, let's see another question that we are given. Then we are now given that on B, given that the area is 16 square centimeters, form an equation in X and show that it reduces to. Okay, now they are talking of area. They are referring to area. Take note, we have calculated our length and we obtained 3x minus 1. That is our length here, which is 3x minus what? Minus 1. Now we are given to say, if the area now of this rectangle that we are talking about is equivalent to 16 square centimeters, we are supposed to formulate an equation which is going to reduce up. So you are not supposed to work out looking at this equation, just reduce, work out properly. Your answer is going to be like that. Okay, so just work out. So how can we form an expression in terms of area? We definitely know that area is equivalent to, this is area of a rectangle. Remember, area of a rectangle is equivalent to length times width, or length. Some they use length times breadth. In terms of width, it's breadth. So it's just one and the same thing. Length times width, length times breadth. So our area is going to be the length. We have our length. Okay, instead we are supposed to substitute here, guys. Let's just substitute at once. So our area is 16. Then you equate to the area, which is length times width. Okay, so length times width, 3x minus 1, that's your length. Your width, which is x plus 2, then we equate to the area, which is 16. So just like this, guys, we have formulated an equation that we can reduce to show that the one that we are given. So what are we supposed to do? Definitely expansion of brackets, 3x and x, which is 3x squared, 3x and 2, which is 6x. We are done multiplying by 3x. We move on to minus 1 and x, which is minus x, minus 1 and 2, which is minus 2. This gives us 16. So just collect your like terms. 3x squared, this is 1 here, so it's 6 minus 1, which is 5x. So it's going to be 5x minus 2 minus 16 is equal to 0. Definitely this 16 transposed to the other side of the equation so that it becomes part and parcel of the equation. So we are going to have 3x squared plus 5x minus 2 minus 16, which is minus 18, and that gives us a 0. So as you can see, guys, that is what we are being asked to show in this condition. That is what we are being asked to show, that it's going to reduce to that value. That's it. Then on C, solve the equation giving your answer to 3 significant figures. So definitely, guys, if you are given to give your answer to 3 significant figures, it's a definite thing that factorization is not going to work. All right, it's a definite thing. Factorization is not going to work. So we have to apply our quadratic formula, completing the square. I don't know which method you are best at, so I'm just going to use quadratic formula in this case. X is equivalent to minus b plus or minus the square root of b squared minus 4ac all over 2a. The presentation that you're supposed to have, this is how your formula is supposed to be presented like. Do not just write the formula, guys. X is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Don't just write as if, guys, because this is an indication to know that what you're writing, you know or you don't know what you're writing about. So your formula, everything under the square root must be covered with the square root, and your division line must be from the start of the point here up to the end, because everything is considered to be divided by 2a. Okay, so what is our a in this case? As you can see, our a is 3, our b is 5, our c is minus 18. So all we need to do is to substitute. X is equivalent to minus b, which is minus 5, plus or minus the square root of b squared, which is 5 squared in this case. So we've got 5 squared minus 4ac, our a, which is 3, times c, which is minus 18, like this. All right, so that's what you're going to have, everything over 2a, which is 2 times 3. So it's going to be 2 times 3, just like that. So this is going to give us minus 5 plus or minus the square root of. So what I want you to do is to use your calculator to simplify this part alone under the square root. Okay, just that stage alone under the square root, because it's very, very important just to show what you have under the square root. In this case, we are going to obtain something like 241. Everything over 2 times 3, which is 6. At this stage, that is where now you can separate your solutions to say you've got a plus and another one of a minus. So your x is going to be minus 5. We separate first one. I'm going to take this plus square root of 241. Everything is affected by 6. Take note, okay? Or another solution, I'm going to take the minus now. So it will be x is equivalent to minus 5 minus square root of 241 over 6. So all you need is your calculator, depending on the calculator that you are using. If you are using those DAL calculators, guys, it's going to be, you're supposed to make adjustments on your calculator like this one. This is how you use your calculator to simplify this at once. You open a bracket, okay, then you put in these values, minus 5 plus the square root of 241. You close that bracket, okay, then you use this division like this. You divide by 6. It's going to give you exact value. The same with this one. That is what you simply do, okay? So, but if you are using a direct calculator like this one, all you just need is to substitute. But now it's because there will be sometimes having too much light, you see, like this. But on this one, you just need to substitute properly. So depending on the calculator that you're using, guys, you're going to obtain 1,754029 and so on. Or another one is going to give us negative 3,42069 and so on. All right, so we are given an instruction about the degree of accuracy that you're supposed to use. In this case, we are given to leave our answers to 3 significant figures, which means you're talking of whole numbers in this case. So we've got 1, 2, 3. So 4 cannot change this. It is going to remain as a 5. So it's going to be 1,75, or here it is going to be 1, 2, 3. This 0 cannot change, so it's going to be minus 3,42. All right, so these are the possible values of x that we are going to obtain on this particular question. All right, let's see another question now. Hence, find the perimeter of the rectangle. So hence, it's a continuation from what you have determined. Use that to determine the perimeter. That is what hence mean. So what you have just calculated, you just calculated the value of x. So using the value of x, now calculate the perimeter. Okay, but we are not going to struggle because already there is an expression for the perimeter, because we are given it has a perimeter of 8x plus 2. So the expression for the perimeter is already there. It's 8x plus 2. That is it in centimeters. So all you need to do is to substitute the value of x that you've determined. Which value of x are you going to substitute now? Because there are two values that we determined. Definitely we are going to work with a positive value because we are talking of length. It's not going to be a negative. We are referring to length in this case. So we are going to work with a positive. So I'm going to take the x being a positive. So it's going to be 8 times 1,75 plus 2. That is the x that I just calculated. Okay, so just like that, guys, this is going to give us 14 plus 2, which is 16 centimeters. This is perimeter. Perimeter in those units as they are centimeters. If it is meters, in meters. Area is the one that you use square units, but perimeter you use the units as they are. So that was it, guys, on this particular question. We move on to question number 8. So on question number 8 there, we are given a particle is thrown. There is a particle which was thrown vertically upwards and its height h. Take note, guys, when you are reading this type of a question, because there are two possible questions that you can have. This is an particle which was thrown vertically upwards and its height h meters above the ground after t seconds is given by the equation. Its height, this is distance, so which means this one we are going to obtain a distance over a time of t seconds. So we are talking of a distance time graph. So this one is a distance time graph. There is another one which relates to this one when they give you speed or velocity. That one is called a velocity time graph. All right, but in this case we are given the height, which is in meters. This is distance. Remember, distance is measured in meters. So distance time graph, you use it. It can be written as a distance time graph, or they can refer to this as height. I want you to cross-check the question paper of, it must be November 2008. Yeah, somewhere there. You see a question which is familiar to this question. And this is what they are just doing, repetition of questions. That is what is just happening there. So I want you to cross-check that question paper and you see that that is a repetition. But it's only that you are supposed to know what to do when working with a distance time graph and what to do when working with a velocity time graph. I think I explained a velocity time graph on a separate class. So we have advantage now. We have got a distance time graph now. So I can explain from this one. There we are given the time and the height in a here, which is h meters. So this is your corresponding time. These are your height. So the first question is to calculate the value of m. So as you can see, guys, this is just a quadratic equation that you see. You just do everything as you do when you are working with a quadratic graph. Everything, because on a quadratic graph, this was supposed to be written like this. If it was a quadratic graph, this was supposed to be written as y is equal to 10 plus 25x minus 5x squared. That is what it's supposed to be like on a quadratic graph. But now they just used another letter. So the concept or the idea, even the shape of the graph is not going to change because it still follows under the shape of a quadratic graph. All right, so that is it, guys. So I hope you understand what I'm saying. So the first question is to calculate the value of m. So you simply need to substitute the value of t, which is 2, into this equation. So that is it, guys. We are given that h is equivalent to 10 plus 25t minus 5t squared, and our t in this case is equivalent to what? At that point where we have m, our t is at 2, so you have to substitute 2 here. So your h is going to be 10 plus 25 into 2 minus 5 into 2 squared. So like I said, guys, this is paper 2. Just use your calculator. You are going to obtain the value of h, which is 40 in this case. So this is 40, which is the value of m. So in this case, m is equal to 40. All right. Anyways, let's move on to the other part. Answer the whole of this part on the question on a sheet of graph paper. Use a scale of 2 centimeters to represent 1 unit on the t-axis, which is the time axis, and 2 centimeters 10 units on the h-axis, which is the distance, the height, the distance. So this is what is going to be like. This is your height, which is your distance, and this is your time. That's a distance time graph. All right. So according to what they gave us, this is what it's going to look like. This is your height, which I said is your distance, and this is in meters. Your distance here is in meters. All right. And this is your time here, which is in seconds. All right. So that is what it's going to look like. Now we are just going to mark our points because all we need is to have this graph. So we are simply going to mark the points 0 versus 10. When t is 0, our h is 10. So when t is at 0 here, our h is at 10. That is this point. So you simply mark that point 0 versus 10. All right. 1 and 30. So it's 1 versus 30. This is your 30 here, 1 here versus your 30 here. Where these two meet, just mark your point in between. Then 2 versus m. Remember our m, we calculate this and it gave us 40. So it's 2 versus 40. 2 versus 40. So it's 2 for x and 40 for h here. 2 versus 40 somewhere here. Okay. Then we have got 3 versus 40 again. And another one we have got 3 and that is 4 and 30. This one 4 and 30. So that's 4 here, x, which is your 4 versus your 30 here. All right, so you simply mark your points properly. 5 and 10. So this is 5 versus 10 here. Okay, your 5 and 10. All right, so make sure all these points, they are visible. Then 6 and minus 20. So we're going to have the last one. 6 here and minus 20 here. So it's 6 and minus 20 somewhere there. All right, so I think all the points are there. So all you need is to join properly the points that you have to produce or to have this graph that you are talking of. So I'm just going to shift it a little bit so that I can maybe produce a nice shape here, guys. But so I'm just putting this upside down, so that is why it is looking like this. But you're supposed to draw, guys, a smooth curve. All right, a very, very smooth curve. Look at this one. I don't know if it is going to be smoother, but here, guys, I'm just using a pen, as you can see, but you are using pencil there, so you're supposed to draw something very, very smoother than this one. All right. And also the other thing, here we are supposed to have a curve here, as you can see here. It's supposed to be a curve. You're not supposed to draw to join these points. No, it's a curve that you're supposed to be a curve there. All right, so mind that, guys, you're supposed to have a curve at this moment. All right, so here I'm just going to put it this way so that I can have my curve here. So I'm going to join these two to this last point here. All right, now I can produce the curve in a nicer way. I'm just going to join. So this curve, at least it must not exceed 3 boxes. At least let it be in between 1 box, 2 boxes, something like that. Not to exceed 3 boxes, guys, or 4 boxes. No, something like this. Okay. Yeah, this one is even too bigger. It's not supposed to be even that bigger. Okay, because it's just a curve to show that these points, they are going to meet. That is where you have your maximum distance, the maximum height that was reached. Okay, at this point. So that is how it's supposed to be, just like. So guys, it's not supposed to be like that. We just draw a smooth curve, very, very smooth. That is what is required, a very, very smooth curve. And also after drawing that curve, don't forget to write also the name of the graph. So the name of the graph is this. So you write h is equivalent to the equation that you are given. So we are given that h is equal to 10 plus 25t minus 5t squared. This is the equation that you are given. All right, so that's it. Like that, you are done. Then that's 4 marks, guys. So what is going to happen is that when you use your graph, it is not going to be exact like what you're going to have. It is not going to be exact. Okay, anyways, let's see item 2. Write down the distance between the initial and the final positions of the object. They're saying write down the distance between the initial and the final positions of the particle. What is the distance between? So the initial point, okay, let's start with initial point. Our initial point, we can even check from here, the graph, from the table, or you can even check from the graph. Your initial point, this one, it's 10. Your final point here, it's what? It's minus 20. So even here, you can take that is your first point here, initial point at 10, and your final point at 20. So the question is, what is the distance between, which means we need to know the difference between these two, 10 and minus 20. So it is going to be 10 minus 20. So the difference is going to be, this is B item 2. All right, so we are going to have 10, that is the first distance, minus the second distance, which is minus 20. So that is our difference there, which is something like 30 meters. So there's a difference between 30 meters, or you can even use your graph to say that at this point, this is minus 20. Okay, this point here corresponds with minus 20 at the last point. The first point corresponds to 10, so you can count boxes from minus 20, that is 10, 20, 30, just like that. All right, you can use your graph just like that. On C item 1, you're asked to use the graph to answer the following questions. Item 1, find the greatest height reached by the particle. So the greatest height, guys, is the one that I was saying, this one that happened at the turning point there. So definitely it is going to be in between these 2 points, in between 2 and 3. So this is what you can do, guys. If you think that you can have a problem on doing this, you can actually find a point in between 2 and 3, because this is in between 2 and 3, like this. Your maximum value will be like this way, in between these 2 points. So you simply take this point to your graph. All right, so taking this point, the turning point, this one, to our graph, the corresponding value is the one that you're going to take. So now, like I said, guys, it depends with your graph and also your presentation that you're going to have. But here, according to this, you're supposed to know the scale of each box. If we are saying this whole box here represents 10, this whole box, it means the smaller box represents 1, like 1, 2, 3, 4, 5 up to 10. So here we have got a point somewhere here at 40, which is somewhere here. So you can say 40 here, 41, 42, this is 43 there. So in between 42 and 43, we can just say 42,5, because we are somewhere here. So you can just say this is 42,5, depending with your graph, guys, or where your turning point is. But according to this one, that is where we have it. So you take where you have the turning point. Okay, so that is how you're going to do it, guys. This is C item 1. So as for me, it's 42,5. I don't know. As for you from your graph. Okay, another way is this point that we are talking about, the value which is the maximum height, it occurs at the point of symmetry. That is where you have got in this case a reflection of the line of the graph in between the mirror line. So that is the axis of what? Of symmetry. That is in between these points, in between. So you're going to see that the value that is going to be in between, if you are to cross check, be in between these 2 points, in between these 2 points, in between these 2 points, you see that it's in between 2 and what? In between 2 and 3, which is according to this scale, guys, in between 2 and 3 is 2,5, because the whole box is 1. So which means each small box is 0,1, 0,2, 0,3. So you're going to count 1, 2, 3, 4, 5. That is a 2,5. That is where we have this. So you can use this method that I'm showing you here. You can use this method to calculate this. Maybe you want to find the exact value. So this one is going to give you the exact value. So at x, which is 2,5, it corresponds with the maximum height. So if that is the case, that at x, which is 2,5 here, at the value of x, which is 2,5, it corresponds with the maximum height. Sorry, not x but t, guys. Remember, it's a distance term. I'm now working with the x and y. It's t. Okay, so at t, which is 2,5, what is then going to be your height? So you simply substitute in place of t, you substitute 2,5. So your height can be written like this. So your height is going to be 10. Remember, it's 10 plus 25t plus 25 times t, which is at 2,5. So this one will give you the exact answer, which is 5 times t squared, which is maybe your graph is not that nice. You can simply use this. Okay, you can obtain your maximum height. Okay, just like that. So let's move on to another question in this case, which is to estimate the velocity of the particle when t is equal to 5. Okay, so the velocity, if you are working with a distance time graph, okay, velocity, guys, I told you that velocity or speed is going to be like how you calculate gradient, okay, on a normal quadratic graph. Here you are calculating the velocity. Yes, its velocity is true, but you are going to calculate that velocity the way that you calculate gradient, because you are using the graph. And how do you calculate the gradient? Remember, we need a tangent that we are to the curve that we are going to use to calculate the gradient. Just the way you do when you are calculating gradient, that answer is going to be your velocity. Okay, so in this case, at t is equal to 5, remember you have to draw a tangent at t is equal to 5. So you use t is equal to 5, which is here on this curve. So you just draw a suitable tangent. So as you can see, our tangent can be maybe somewhere there, somewhere like this. All right, so maybe you've drawn your tangent, so it is not going to be exact. It depends with your graph, because this is like an estimation that you are doing. You are not finding the exact thing, you are actually estimating, because it's from your graph that you have drawn. It's not exact. So you're going to take two possible values, then you calculate your gradient. That will be your velocity. So the first point definitely is at a point where t is equal to 5, which corresponds with what? With 10. So we have got the point 5 versus 10. That's a point that you're going to take. You take another point because you want to calculate gradient, just like gradient. So you can take this point according to this graph. I don't know, it's 5,1, 2, 3, 4, 5, 6. So according to my graph, it's 5,6. So you just take 2 points, and our gradient is not going to be the exact. So this gradient that I'm going to calculate in this case, the way of calculating the gradient is my velocity. So we know that gradient is the change in y over the change in x, which is we are going to use y2 minus y1, which is 0 minus 10, over x2 minus x1, which is 5,6 minus what? Minus 5. So by doing this, guys, I'm going to obtain a certain value, which is in this case is representing what? Is representing my velocity in this case. So in this case, I'm going to have 5,6 minus 5, which is 0,6. So I'm going to divide by 0,6, which is negative 16, something like that. Negative 16,666. So like I said, it depends with your value that you have. So you just take this round off properly, and your velocity is measured in meters per second. But the idea is this: you have to calculate the gradient, just like the gradient, or you can use this concept, increase in y over increase in x. So what you simply do is that you just draw a smaller right angled triangle, just like this. A smaller right angled triangle like this. I'm going to take this smaller right angled triangle like this one. Then you do the movement increase in y over the increase in x. So it's increase, change in distance over change in time. That's velocity. So you can calculate the boxes, number of boxes over number of boxes. You must obtain the same value, or like not the same value, but something that is an estimate to the exact thing. Okay, so that's how you do it. So I shall come again with other method that gives exact values, but those ones, they're actually not part of your syllabus, but you can just maybe know them because they give you the exact thing. All right, find the times at which the particle is 21 meters above the ground. Okay, it's 21 meters above the ground. What is the time? So we simply need to go to the graph. Where do we have 21 meters? 21 meters, remember we said each box here is representing 1. So this is your 21. You just count one box above that. You draw a horizontal line. You say this is 20. Then you move one box up. That is 21. So this is where our height is 21 at this point, or at this line. Our height is at 21 meters. Now the question is saying, what is the corresponding time at those heights? So the time is in this axis, so you have to relate back to your t-axis. So back to your time axis, you take the value there. Back to your time axis, you take the value there on your time axis. All right, so that is it, guys. At a height of 21, this is where our height is 21 meters. What is the corresponding value of t? That is the one that, so just take according to your scale, 0,1, 2, 3, 4, 0,45 according to my graph. I'm obtaining 0,45. Okay, guys, let me just use this one. 0,45 seconds, and another one is at this value. You just correspond at this value. What is the corresponding value there, which is here? So it's 1, 2, 3, 4, 5, something like 4,5 at 4,5 seconds. So you just, these values, guys, you are estimating everything that you take from your graph. It's an estimation, because you remember you are the one who drew this graph, and it was not exact because of your smoothness. So also make sure that your graph is very, 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 very smooth. Okay, so that's it, guys. We can see another question. Let's see another question. So on this particular question, you are given that on number 9, there is in this case where we are given the cross section of a solid prism. So this is a solid prism, as you can see, that is 50 centimeters long. So as you can see, guys, this cross section here that you see on this end is the same as the cross section that we see on the other hand there. So this is very, very important. Here we've got a cone that we see on this end, and we also have a cone here. It's very, very important. So every solid like that, for you to calculate its volume, you calculate the base area of 1, then you multiply by the height to that Okay, so the question in this case is, we are given this, it's a sector AOB that we have the radius 6 centimeters and an angle of 80 degrees. The first question, calculate the length of arc AB. This is the length of arc from this point to this point here. That is your AB. So that's it, guys. Remember, length of arc is taken from the perimeter of a circle. So it's going to be length of arc is equal to theta over 360 times 2 pi r from the circumference of a circle. Just an angle that you have taken, not the complete circle, but it's a piece of a circle that you're going to take, which is out of 360 you're going to just take 80 degrees. So it's 80 over 360 multiply by 2 times pi. Your pi is given as 3.1. You use the pi that you are given on the question paper, not just any pi. To say 22/7, you use the pi that you are given in the question. So in this one you are given 3.142. that is one that you use, times the radius, which is 6. So just like that, guys, that is what you're going to have. All right, so using this, guys, we are going to obtain something like 8,3, that's 8,37866, which is going to be 7866 and so forth. So 3 SF is going to be 38. Okay, that's our length of arc in centimeters. So make sure that you use your calculator properly, guys. But I think that's what you had. Let's see another part, which is the total surface area of the prism. Okay, so item 2, need the total surface area in this case. Okay, so this is what is going to happen, guys. For the total surface area, we are going to calculate this area here, the area of this sector. Okay, we've got this sector here times 2, because there are 2. Then on the base there is a rectangle. There's going to be, because it's like this, guys, we are talking of a cone, we are talking of a sector, which gives us something like this. So this side here is going to be joined to another side like that. So definitely there's a rectangle of this nature. And also this side, it will be joined to another again side like that. So definitely there is a rectangle there. So we are going to have 2 rectangles with the same properties. Okay, and 2 sectors with the same properties. Then there is a curved part on top, this one, which consists of AB and 50 centimeters. This one, a curved, because on top it's curved there. So it's going to be total surface area. You add everything. Okay, so that is your total surface area. So our total surface area, guys, is going to be this is item 2. So our total surface area, we said area of a sector times 2, and we say area of a sector is equivalent to theta over 360 times pi r squared. That is the area of a sector. So in this case, theta times 2 now, because there are 2 of them. So that's what you're going to do. 80 degrees over 360 degrees multiplied by, in fact, there's no need to rush to height. Okay, pi r squared, which is pi 3.142. remember the pi that you're given, 3.142 times r squared, which is your radius squared of 6. So it's going to be 6 squared. But these sectors, there are 2 of them, so we're going to multiply by 2, plus we have got a rectangle here of OB, which is 6 centimeters times 50 centimeters to the other end. So it's 6 times 50, and also here 6 times 50, there are 2. So it's going to be 6 times 50, and there are 2 of them. Plus the last part, which is the area of this shape. There is length here times the height, which is the length of AB times what? 50. So remember AB, we calculated B, it was something like 8,379, something like that. That's what we have, times 50. So you take that AB that you calculated, the length of arc, this one, times 50. So everything is going to give us the total surface area in this case, guys, which is going to be you just have to do your things properly and add, which is going to be something like 1069,2222, something like that, in square centimeters. Okay, what is important is the areas that you're going to take. All these calculations, how you're going to subdivide them, how you're going to make them, is something else. But what is important, how you're going to take that area. But that's what you had on this part on the total surface area. Let's see another part of the question. Now we are given on 10b. Now it's another question where we have got a triangle in this case, and we are given to find the value of cos AB. We are given 7 centimeters, and we are given that sine BAC is equal to 2/3. That is BAC, sine of this angle is equal to 2/3, where BAC is an acute angle, and we are told that it's an acute angle. So find cos BAC. So guys, this is direct. Okay, we do not have the angle first that is called BAC. This angle is not even there. We just know that there is our B, there is our A, there is our C, in this case 7, 9. This is BAC. We do not know this angle, but we are given that sine BAC is 2/3. So which means we must obtain an angle from this. Sine BAC is equivalent to 2/3. So how do I obtain angle BAC? Remember, how do you remove sine from one side to the other side? Is you're going to write this as arc sine. So BAC is equal to arc sine, which is shift sine on your calculator, 2/3, depending with the shift. Yeah, now at these calculators now, some of them, it depends which way you have, but you see that on your sine there is this sign, then on top of that there is that arc sine. So maybe it's in yellow or it's written in orange. You have to access that. So some they use second function, second function sine or shift sine. Okay, so this is going to give you an angle that is in between that part, okay, which is in this case 41,8, something like that. So it's going to be 41,810, and so forth and so forth. So that is our cos, that is our cos that is our angle that we are obtaining actually. But now the question is not about this angle that we are given. We want to calculate the cos of that angle that we have, the cos of this angle. So what you're going to have now is cos BAC is simply means cos of this angle 41,810, and so on. The value that you obtained is 41,810,314, and so on. So you calculate that value now. That is cos answer. So you're going to obtain 0,7453, something like that, which is 0,745. That is your cos now. So cos BAC, guys, we are saying we must calculate angle BAC, which is this one, BAC, which is 41,8. If I have got this angle, guys, and you're asked to calculate cos BA, I simply use my calculator, cos 41,8 on my calculator, but I couldn't do this because the angle was not there. So that is why we have to apply the part that we had sine to calculate the angle, then to calculate our cos, which is this answer. The question needs you to find the value of that cos, so you need the decimal part. All right, so that's the case, guys. Then the length of BC, so definitely we can apply our cosine rule because we are given two sides and an included angle. We want to calculate the third side. So remember your cosine rule. To find the third side is a squared is equal to b squared plus c squared minus 2bc cos a. So that's it, guys. We want to calculate BC, so it is going to be BC squared, which is equal to B and C. These are the sides which are creating the angle that we are talking about, which is 7 and 9. So we've got 7 squared plus 9 squared. Any order, you can start with 7, you can start with 9, okay, minus 2 times 7 times 9 times cos A. Cos A is this angle that you're talking about, which is the one that you have already calculated. So already we calculated this cos A and we said is what, 0.745. So this is the one that I'm going to use because already I calculated these guys. All right, so to find BC we have to simplify, guys. 7 squared plus 8 squared. Okay, just combine these two, you're going to obtain something like 113 minus, we multiply these, we are going to obtain something like 83.44. So you can use the actual values or these ones, your answer is going to be the same. BC squared is equal to, you subtract these two, which is going to be 29.56. if you subtract properly, guys, then the square root to remove the BC, the squared on BC. So BC is equal to, what is the square root of the answer that we have, which is 5.4369, something like that, which is going to be 44 if you round off, maybe 3SF, because it's 5.436, something like that. So this is going to be 1 2 3 6 changes this into 4, so that's what you're going to have. So issue of rounding off of values again is another thing that you're supposed to learn and work on, because it's something that you must apply. As you can see, guys, you have to apply that. And on number 10, we are given an agriculture class studied the effect of a certain chemical on the growth of 30 moringa seedlings. The height of the moringa seedling are shown in the frequency table. That is the one that we have. Write down the model class. So as you know, the model class is the one with the highest frequency. So which one has got highest frequency? That is the one with 10, which is 25 to 35. That is the one with the highest frequency. So in this case, that's your model class. You don't take the height of 10, you take the class 25 and write as it is, guys, the way that it is written here. So h is greater or equal, is greater than, sorry, h is greater than 25, less or equal to 35 as it is. So that is your model class, the class with the highest frequency. The highest number on frequency is 10. So what is the class that is corresponding? That's your, okay. If this information is represented on the histogram, the question is, if not represent, an assumption that, let's say, if it was represented, what was going to be the frequency density for the following class of 10 to 20? From 10 to 20, what was going to be the frequency density? So we know that frequency density, guys, we are supposed to have this from this formula. Frequency density, remember I told you, is frequency over the class width. Frequency on that class over the class width of that class. So the frequency of from 10 to 20, that is 10 to 20, what is the frequency? Our frequency is 5. So that is 5 over the class width. Class width, what does it mean? It means upper class minus the lower class. So you simply subtract the two. That is 20 minus 10, and 20 minus 10, which is 10. So this is going to give us 0.5 from our calculator. If we do this properly, that is our frequency density, just like that. Okay, we move on to another one. The frequency density for this class 35 to 40, that is 35 to 40. This one we said frequency density, it's frequency over class width. So I'm not going to repeat the formula, already written this. So frequency from 35 to 40, what is our frequency? Our frequency is 9 over the class width, upper class minus lower class. So it's 40 minus 35, which is 5. All right, so that's it, guys. If you divide, this is going to give us, that is 35 to 45, 35 to 40, guys. Okay, so this is going to be 5. Okay, so it's going to be 1.4, if I'm not mistaken here. It's going to be 1.4, something like that. 9 divided by 5, which is 1.8. Sorry, that's 1.8. You see this issue of not wanting to use a calculator while you have a calculator. Okay, this is 1.8. All right, so guys, make sure that you use your calculator. All right, make sure that you use your calculator properly. Anyways, let's move on to C. Calculate the size of the angle that would represent the class of on the pie chart. You are not told to draw a pie chart. You are just told to calculate an angle that could have been used if we had to draw a pie chart from this information from 35 to 40, okay, remember on a pie chart the angle is given by this. So this is item C. Okay, remember the angle on a pie chart, theta, which is in degrees, is given by, or this is how you calculate that theta. It is given by the frequency for that class, like the frequency for that class that you're talking about, okay, over the total frequency times 360 degrees, because remember you're working with degrees, so you multiply by the total, which is at 360 degrees. So that is the frequency at that class. Which class are we talking about? 35 to 40. Okay, so 35 to 40, this is our frequency here, which is 9. So it's 9 over the total frequency, which is the total number of seedlings that we have, and we are given that there are 30 moringa seedlings. So that is your frequency. The total frequency is what? Is 30. So over 30 times 360 degrees. So just like that, you are going to obtain an answer measured in degrees. This is paper 2, guys. Use your calculator. All right, you're going to obtain 108 degrees in this case. That's it, guys. Then on number D, we are now asked to calculate an estimate of the mean height. What is going to be the estimate of the mean height now? So remember, guys, mean, you have to use the class center. So in this case, I'm just going to show you what you're supposed to do. Okay, so in estimate, you're going to use the class centers. All right, that is mean. All right, so remember you have the sum of terms over the number of terms, but you use the class center because this is you are talking of what? Of group data. So you have to calculate the class center. You multiply it like this. You calculate the class center for that class. You multiply it to its corresponding frequency. You move on to another class. You calculate the class center for that class. You multiply it to its corresponding frequency over the total frequency. That is what you're going to have. So in this case, class center, remember how you calculate class center is the upper class. That is your class center. You simply add the upper class plus the lower class, then you divide by 2. That's it. Upper class and lower class divide by 2, or lower class plus upper class divide by 2. It's just one and the same thing. All right, so what am I simply saying? You add this to 10 plus 20, which is 30, then you divide by 2. So that is what you simply need in between 10 and 20. Okay, so it's going to be 15 times 5. In between 10 plus this, which is 30, divide by 2, which is 15 times 5. So that is how you simply do. That's your class center. So we have said 15 times 5 plus, you move on to this one, 20 and 25. So you add 20 plus 25 over 2. You add this like this. So you're going to obtain 22,5 times 6. You move on, 22,5 times 6, and so on. So this is what you're going to do. You move on to another one, 25 and 35. There you're going to obtain 30 times 10. You move on, and the frequency, which is 10, 35 and 40. If you add this, you're going to obtain 37,5 times the frequency there, which is 9. So that's how you simply do this. Everything over the total frequency, and your total frequency is, remember, 30. So that's the concept, guys. You calculate, you add everything, that will be your mean. So this value, you obtain an answer, you add, and so forth. Okay, so guys, this video is now too big. Let's see another part, but that's what you are supposed to do there. If 2 seedlings are picked at random from the probability, find the probability. So they are picked at random, then find the probability that one is at most 20 centimeters tall and the other is more than 35 centimeters tall. So when we say at most, which means that is the highest value that we can have. So which means you're talking of a height that is less than or equal to 20 centimeters. That is the highest possible height that we can have. So in this case, we are talking of a height that is less than or directly equal to 20, which means you're talking of this here. where we have got h being less and less than or equal to 20, which means we're talking of this region, and how many elements are there? We have got 5. So this is 5. So your probability is going to be 5 over the total, which is 30 times. You move on to another one. The other one in this case, they are saying is more than 35 centimeters, which means we're talking of h being greater than 35, that is being more than. Okay, so where do we have this h greater than? We have got here h greater than. Here h is pointing 35, which means h is greater than. And how many elements are there? It's 9. So this is going to give us 9 over the total. So now it depends, guys, is with replacement or without replacement. But here we've taken from 2 different sets, so you can use with replacement. If it is with replacement, therefore this is what you're going to have. Then you have to reduce your values. If you use without replacement, then it is going to be 5 over 30 times 9 over 29. This is for without replacement. This is for with replacement. All right, so indicate the method that you have used there. So that's what you're going to have. You simplify, guys, using your calculator. This is going to give us something like 5 over 30 times 9 over 30. So it depends like which one have you taken there. The first one is going to give us 1 over 20 for with replacement, and this one you can obtain something like 3 over 58. So, and also probability you can also write as a decimal fraction, so you can even put your answer as a common fraction or just like that. I don't know, the one that is best for you. And I don't know, guys, if we are able to finish this part. Let's see. On number 11, we've got a question on transformation. So I think transformation, guys, we've managed to work on separate videos, classes, and so forth. So we just hope that everything is going to be clear. In this case, we just hope everything is clear. So you're given a question to answer the whole of this question on a sheet of graph paper, and you're given a scale of 2 centimeters to 2 units on both axes, and you're given our x from minus 10 to 8 and our y from minus 4 to 8. Then we are given. Okay, so this is what I'm going to do. Let me put it this way. Lots of time, guys, so I'm just going to show you what it was supposed to be like. Your ABC, you mark your points, triangle A, B, and C, you mark your points properly, then you draw your triangle. That's your ABC. All right, then after that you are given that triangle A1 B1 is vertices at, these are the vertices of the triangle. You draw, you mark your points A1 B1 C1 as they are. That's your A1 B1 and C1. These are the points. Okay, so you're done. You've drawn the first one and the second triangle. Okay, now we move on to C. Describe fully the single transformation which maps ABC onto A1 B1 C1. Okay, so this part alone means this here is your object, because this one that is one that is being mapped onto this. So this one is your image and this is our object. So what we need to see is the type of triangle that we have. Okay, if I am to cross check this triangle here and this triangle here, they are the same. Just look at this triangle, they are actually same size, everything. So which means in this case, if they are of same size, like sorry guys, all right, this now because of this graph, but we are having that the size is the same. So which means in this case, for us to use this concept, we are going to look for these things. We have to cross check either we are working with a translation, its rotation, or is what is reflection. Which one is the best that we are going to use? So in this case, we are producing parallel lines. If we join these points A to A1, B to B1, C to C1, we are having parallel lines of equal length in this case. So what does this mean? It means we are working with a translation. It is only translation that can do this. To have parallel lines of equal length, it is only translation that can do this. Remember, a reflection, we are going to have parallel lines, but they are going to be of an equal length. Okay, what I'm saying when I'm saying of equal length. This is it, guys. You measure your points in this case from A to A1. You just have to measure your points here. This is your A and this is your A1, this point here. Okay, you see if it is the same also from B to B1. This is your B and B1. As you can see, they are the same. You see about C and C1, you see it's the same length again, so they are of equal length. So it's only translation that can do this. So now we can describe it is a translation. So this is item C, so it is a translation. What else do we need in this case for translation? We need the translation vector. Translation vector. All right, so in this case, what is the translation vector? How do you find the translation vector? Remember, translation vector is equivalent to the image minus the object, but you have to write it as an a vector, like the point as a vector. So you just choose corresponding points from your image. Remember, A1, B1, C1 is your image. We said this is our image, this one. So you take from the image back to the object. So you see, like the presentation, these guys, these graphs, they have too small. These boxes are too small, so that is why you see it's like vibrating like that. It's like trying to figure out what's happening because these boxes, they are too small. You see, I do like this, everything is fine, but because by doing like this, it will be trying to figure out. Okay, anyways, let's just quickly do this. So it's going to be A1 minus A, that is image minus object. So just guys, try to understand, don't mind that thing, what is it is doing. So it's going to be A1 minus A, or it can be B1 minus B, or it can be C1 minus C. That's your translation vector. You just choose any of your choice. So I'm going to use A1 minus A, like that. All right, so if I choose A1 minus A, okay, that means our A1 is this point minus 2, 2, minus 2 for X. You take the point, this one, you just take the point A1, which is minus 2, 2, of which we have got these on those points that were written. So if you are confused, you can even come back here and take here A1 here and your A from this point. So A1 is minus 2, 2, as long you are taking corresponding points. Minus A, your A here is 2 minus 2. All right, so just like that, that's your vector. Minus 2 minus 2, which is minus 4. 2 minus minus 2, which is 2 plus 2, that's 4. So that's your translation vector, guys. So I can just prove this maybe using B1 minus B. Okay, I must obtain the same answer. This is B1, which is 0, 6. So you can even take it from your graph, minus B, which is B is 4, 2. So that's 6, 0 minus 4, which is minus 4, 6 minus 2, which is 4. So as you can see, you've got the same translation vector. So you can work it any way or anyhow. So that is what we had. So let's move on to another question now, which is on the triangle ABC is mapped on triangle A2, B2, C2 by a reflection in the x-axis. Draw and label triangle A2, B2. Okay, so a reflection in the x-axis, guys, is like this. This is what you're going to have it in actual sense. I've already drawn this because of this graph, how it does, but this is what you're supposed to do. This is your x-axis, is a reflection in the x-axis that we are given. All right, so if it is a reflection in the x-axis, it means this point A is going to be transferred along the x-axis. All right, so you move to the x-axis from A to the x-axis, that is 1 unit. As you can see, we are using upward 1 box, so you go upward 1 because you're saying this is your mirror line. So your image of A is supposed to be on the other end there. So if you move 1, you move 1 upward. This is the image of what? Of A, which is now your A2, this one, which is your A2. You do the same with B. But as for B, guys, this is B. Remember, this is your mirror line. The x-axis is your mirror line. But your B2 is on this side of the mirror. So definitely, this is your B. which is the object, is on this side of the mirror. So your B2 is going to be on the other side because it is the image, so it is going to be across the mirror line. So you move this time one box going downwards to the what? To the mirror line. Then you move again one box. Remember, distance to the mirror line is same distance to the image. So you move one to the mirror line, one to the image, because your image for B is along this. Okay, so this will be your B2. You do the same with C. C is across the line, so you move one distance to the mirror line, then one distance downward, which is your C2. Then definitely you have to join these points, like you can see this triangle here, which was including this one. So it is going to be like this. So your C2 is where at this point. Your B2 is now at this point. That is how you simply take that one. All right, so that was a reflection in the x-axis. And on E we are given to draw triangle A3, B3, C3, the enlargement of triangle ABC about center minus 4, 2 and scale factor minus half. Okay, I always say it's easier for you to use matrix for this type of a question. It's going to be easier for us like to work it that way. All right, it's going to be much easier for us to work this question that way, because if we are to use the graphical presentation, yes, it's fine, we can do that, we can have our graphical presentation, but it is best that we just have our matrix used in this case. All right, so I hope you understand what I am trying to say. And the other thing that I wanted you to see, that I wanted guys, this part here, we described the first question. All right, then here we drew this triangle. I want to neglect this one. I want to come back here, and I'm seeing that I can have another method that I can explain. I'm going to come here. We are given to draw this triangle A2, B2, C2. Okay, by a reflection in the x-axis. Maybe you didn't understand the way that I was, the movement part, because I'm sensing that maybe someone you didn't. So maybe you didn't understand that way. We can go back to our reflection, guys. Remember, reflection, we've got a matrix. Matrices, in fact, matrices for reflection in the x-axis, in the y-axis, in the line y is equal to x, in the line y is equal to minus x, which you need to know all those matrices, and I explained them. So we said matrix for reflection in the x-axis is given like this. Let me write it this way. So we are back to that D. We will move on. The matrix for reflection in the x-axis, we said, is taken from our x here, our x-axis and y-axis, which is at 1, 0. So we are going to have this as our, I'm not explaining everything here, guys. You have to watch those videos so that you can understand more. So in the x-axis, this is your mirror line, so it's going to remain at 1, 0 here. Then in the y-axis, this point is going to be reflected along this point, which is at 0, minus 1. So this is the matrix that we have for reflection. Okay, guys, sorry, this is a matrix that we are going to have for reflection. Okay, but we are saying this matrix times the object must give us the image. So matrix times object, and our object is triangle ABC, which is these points A, B, and C. So it's 2 minus 2. You move on to B, 4, 2, which is 4, 2. Our C, which is 6, 2. So you can write this as A, B, and C. So you apply your row by column. After that, the answer that you are going to obtain definitely is your image, because you are saying matrix times object, it gives us the image. So row by column, that's 1 times, you can even write here 1 times 2, which is 2, 0 and minus 2, there's nothing here. 1 times 4, which is 4 plus 0 times 2, there's nothing here. 1 times 4, 6, which is 6 plus 0 times 2, there's nothing here. 0 times 2, there's nothing. Minus 1 times 2, which is 2. 0 times, we have now this row 0 and 4, there's nothing. Minus 1 and 2, which is minus 2. 0 and 6, there's nothing there. Minus 1 and 2, which is minus 2. So that's what you're going to have as your image, which means you're talking of the object, we're talking of the image, which is A2, B2, C2. So this will be your A2, which is 2, 2, your B2, which is 4, minus 2, and your C2, this one, which is 6, minus 2. So you can even use matrices. As you can see, if you are to mark these points back, you see that A, which is 2, 2, that's your A, which is A2, which is 2, 2 here, same point. B2, 4 minus 2, B2, 4 minus 2, we have got same point. C2, 6 and 2, 6 and 2, which is minus 2, 6 and minus 2, sorry, why am I, okay, this is minus 2 actually here, as you can see, so it's 6 and minus 2. So we have got the same diagram, the one that we had, just like what we have done before. You can use matrices. So that's what I'm saying you could have done. So in this case, we have got the same concept, but this time on E, we are given a matrix for enlargement. We need matrix for enlargement that is going to be best for us. So on E, for us to use this matrix for enlargement, remember it's enlargement K 0, 0, K. That is the matrix for enlargement where K is the scale factor, and in this case our scale factor is minus half. So we've got minus half, 0, 0, and minus half. But remember, I told you for enlargement, this matrix to be used, it must be on a condition where center is 0, 0. And in this case, our center is not 0, 0, which is minus 4, 2. And remember, guys, on the introduction of matrices, that whenever the center is not 0, 0, you subtract the center first from the coordinates of the object. Okay, so you have to subtract the center first from the coordinates of the object. And what is our object? Our object is ABC, because you are mapping this ABC, which is 2 minus 2, 4, 2. You just write this as a matrix, 6, 2. As a matrix in that order. That's your A, your B, and your C, your A, your B, and your C. So the first thing is to remove the center, because you are not at 0, 0. So remove the center, subtract the center that you are given, because in this case our center is minus 4, 2. So how do I remove it? I write it just like as a matrix, minus 4, 2, like this. That is to remove the center, to subtract the center. So it's 2 minus minus 6 minus minus 4, which is 6. 4 minus minus 4, which is 8. 4 plus 4, that is 8. 6 minus minus 4, which is 10. Minus 2 minus 2, that's minus 4. 2 minus 2, that's a 0 here. 2 minus 2, that's a 0. So I have removed the center, which means I am now at what? At 0, 0. So now I can apply this matrix, because it only operates when the center is at 0, 0. So I can now multiply matrix times object, so that I can have the image where my matrix is minus half, 0, 0, minus half. All right. So just like the previous part, guys, we have to multiply properly. Okay. I think here, let me just remove some other stuff here. All right, so just like other multiplication that we have, we are going to multiply our row by column, which is minus half and 6. So minus half and 6, 0 and 4, and so forth. So it's minus 3, minus half and 8, which is minus 4, minus half and 10, which is minus 5, because this 0 is going to give us a 0 throughout. We move on, this 0 is going to give us 0, 0, 0, so it's minus half and 4, which is 2. Minus half times 0 here, that's a 0, minus half times, which is a 0 there. So we have multiplied by the matrix. So what is left? We have to add back that center that we removed in this case. So in this case, you have to add back that center. Okay, so we subtracted the center, then we add back that the center. All right, so if we add the center, this is going to give us, that's a 1 there, minus 3 and 4, which is a 1, minus 4 and minus 4. If you add, that's minus 8, minus 4 and minus 5, which is minus 9. 2 plus 2, that's 4. 0 plus 2, 0 plus 2. So that's the idea that you're supposed to have, like what it's supposed to look like from this presentation. So this will be your image, which means with these coordinates we are able to mark, guys, 0. Hey guys, this, I'm now tired, I can see now I am tired, guys. All right, because we are adding here 0 plus 2, that's 2, 0 plus 2, that's 2, minus 3 plus minus, this is minus 7. We're just adding there. All right, so these are the coordinates, minus 7 and 4, okay, minus 8 and 2, minus 9 and what, and 2. So these are the points that we are going to work with, these ones. So you actually, when you actually have these points, all you need is to mark them, minus whatever that you have here, minus 7. These are the points here. That's our A3. We are now at, guys, okay, let me cross check here. Where are we now? We are now at A3, B3. So this is our A3, B3, and C3. Okay, so now according to this graph that we have, minus 7 and 4, which is going to be here, minus 7 in between, minus 2, minus 6. So minus 7 is supposed to be in between, guys. All right, minus 7 and 4. And minus 8 and 2. So guys, I need you to correct this one, because minus 8 and 2 is this one actually. Minus 9 and 2, which is in between this one. Then minus 7 is supposed to be here. Minus 7 and 4 somewhere here, which is 1, 2, 3, 4, 5, somewhere here, guys. All right, so it's supposed to look like this. So I want you to correct this one. It's supposed to be like this. Minus 7, this is your A3, so it's supposed to be here, not here, guys. You see this issue of working these 4 papers, you'll be so tired. Anyways, I hope the idea they have is, so this one is not there, you're working with this and this and this. All right, now it can make sense. Let's see another part, which is V. There is defined as with the matrix draw and label. So this one is the direct application. You are given a matrix, nothing to think about what type of a matrix, which shape is, what is it going to look like. Just apply your matrix, because you already have the matrix direct here. Matrix times object is equal to image, just like that. So that's our F here. Matrix times object is equal to image. The matrix that you're given in this case, we have our matrix. So 1, 0, minus 2, 1 by the object. So you just take your object, which is what, your ABC, because here transformation is V, but it's the image of ABC. So your ABC is not changing, guys, as it was 2 minus 2, and you move on 4, 2, that's 4, 2, and 6, 2. So that's it, guys, your A, your B, and your C. So just like this one, we have to apply normal because we have got other values here. So row by column, 1 and 2, which is 2, plus minus 2 and minus 2, which is going to give us 4. Okay, we are done with this row. We move on to this column, 1 and 4, that is 4, minus 2 and minus 2, which is minus 4. We are done. We move on to this column, 1 and 6, which is 6, minus 2 and 2, which is minus 4. Okay, move on to this row now. We repeat those columns this time. So it's 0 and 2, which is 0, 1 and minus 2, which is minus 2, 0 and 4, that's 0, 1 and 2, which is 2, 0 and 6, which is 0, plus 1 and 2, which is 2. Okay, so we just add properly here, which is going to give us 6. Okay, and 0 minus 2, that's minus 2, that's 1 is a 0, 2, this one is 2 and 2. So these are the points that you're going to actually have, and this becomes our A3, B3, and so forth. So we just have to, it's now A4, so this will be your A4, B4, C4. So you mark these points, 6 minus 2, that's your A4, 0, 2, that's your B4, and your C4 will be 2, 2, like that. Okay, so using these points, mark them properly. That's how it is going to be. Like that will be your A4. That is 6 minus 2. 6 minus 2 here is going to be where C2 was. So that's your A4. 0, 4, 0, 4. This one 0 versus 4 here. That is where we are going to have our B4, guys. That's 0, 4 or 0, 2. 0, 2, 0, 2. Guys, I'm tired. That's 0, 2 here, which is this point, and 2, 2, which is 2 versus 2 at this point. Or that's 2. Okay, there's something that we might have done, but this is actually 2 because here is 2, so which means the point that we have is supposed to be here. This point, our A4, our B4, right? Then our C4, which is at this point at 2, 2. So it was supposed to be here at 2, 2 here. So you're supposed to join these points here like this, back to this point like that, right? Like this, like this. So this is your C4. All right, just like that, not here. So I think by like that it can make sense. All right, so as you can see, guys, all these is just that we need to work as much as we can to prepare ourselves so that we'll be able to partake in the exams that we are having. But actually that's how these questions they are being asked. So all you need to do is to work on much questions and revisions from what you have, because this one just an application of the matrix that you be given, especially using matrices. I consider that to be something that is best. So that's it, guys, from this question paper that we had, working with the full paper, so that we can be able to revise, guys, as much as we can. So let's just keep on revising, working on more question papers and revisions also. That one, it can actually help us to prepare for the exams which are ahead of time, and I think that's the best for us to do for now. So that's it, guys, till we meet again.